Yes, sir.
Good morning to all.
Yes, we are listening.
Yes, okay, thank you, sir. Dr. Sujit,
We will start today's program. Lead lecture, session lead lecture third,
Yes, sir.
with the first lecture on ensuring residue-free milk, challenges, health concerns, and future strategies. And the speaker is Dr. Anil Bikane, sir, ex-director of research, Maharashtra Animal and Fishery Science University, Nagpur. Sir, I welcome you today for this session. Dr. Bikaner has done extensive work on animals in breeding and other aspects. He's a good academician and a good extension worker. So, with this introduction, I uh, request Dr. Bikaner sir to start his presentation.
thank you, sir. Thank you. Dr. Sujit, please share my presentation.
Yes, sir.
काय झालंय?
Sir, uh, sir, presentation is visible.
Yes, yes, it's visible. One minute.
Sir, please start your presentation.
Okay. Thank you. Thank you. Just... So, good morning, all of you, for this. I think it's the second day of National Seminar on Sustainable Indigenous Cattle Farming. And we are opening the second day with this lead paper on ensuring residue-free milk, challenges, health concerns, and future strategies. Next slide. This is actually a very important topic of consumers' concern. Please. Next. Next. So actually milk is considered as a complete food, which is as it is rich in proteins, fats, vitamins, minerals, and carbohydrates. And you all know that India leads global milk production. India ranks first in the world since 28 years and contributing 24 to 25% of the global milk production. Although this is the scenario as far as production is concerned, but as far as the export of the milk and milk products from India is concerned, the contribution is just 1%. Means we are producing 24% of the milk of the world. However, our export contribution is just 1%. And the reason for this less export, one of the reason is a quality of the milk. For increasing the milk production, the intensive dairy farming practices they have been adopted. High producing animals we are maintaining. these high producing animals, if they are not managed properly, if they are not fed properly, then they are susceptible to the different diseases. And when they suffer from one or other disease, the drugs they are to be used. And that is one of the most common reason for the milk residues. But nowadays, there is increased demand for the residue free milk due to growing awareness regarding food safety and public health. So now there is a very good awareness amongst the at least learned people about the food safety and public health, and therefore the demand for the free milk is increasing. Next slide. So there are four major types of milk residues which are encountered in the, you can say, the milk. And this classification has been done based on the origin of the, you can say, the residues and pathway of entry into the body. Number one is the veterinary drug residues. The antibiotics, the commonly used for the treatment and prophylaxis of mastitis, metritis, and several other infections. And usually, the antibiotics found in the milk, they are penicillins, tetracyclines, maybe macrolides or fluoroquinolones and sulfonamides. So most commonly, the antibiotics, they are found in the milk. They are one of the commonest, you can say, the residues in the milk. Second, those are pesticides and agrochemicals. Usually pesticides enter the dairy supply chain primarily through the feed crops, which are sprayed or treated with the pesticides, or through direct application or topical application of ectoparasites on the animal body and even in the herd. That is the another reason for, you can say, this pesticide agrochemical residues. Third major and important is mycotoxins. Dairy cattle, they consume the feed contaminated. When they consume the feed contaminated with aflatoxin B1, that aflatoxin B1 is metabolized in the liver to aflatoxin M1, and which is excreted, or you can say which is secreted through the milk in 12 to 24 hours. So fourth one is the heavy metals and pollutants, particularly in environmental pollution is responsible. Increase in the urbanization, increase in the industrialization that has led to the contamination of the forages as well as feedstuffs, forages, as well as the groundwater. And animals, the lead, cadmium, arsenic, mercury, these are the heavy metals which are secreted through the milk, and they bind to the milk proteins and secreted through the milk. And as far the pesticides are concerned, they bind to the milk fat. Next slide, please. From farm to milk can, where residues can first enter the chain, how you can say the residues, they can enter at a different steps. On the farm, actually contaminated feed and fodder leading to the fungal toxins. This is one of the, on the farm, or the environmental pollution may be irresponsible. Treatment aspect, particularly antibiotics and hormones given during treatment or milk dead down. Usually hormones, they are given for milk dead down, and antibiotics, they are given for the management of the infectious diseases. That is the another, you can say, the way. Third is the feed and fodder. This is the pesticide exposure from crops or direct application on the animals. So that is the another, you can say, a step or through which you can say the residues, they enter the chain. Then during milking also, poor hygiene and dairy chemical misuse may lead to milk residues. Storage and transport, improper storage of the milk, improper transport of the milk may lead to even some abnormalities in the milk, or it deteriorates the quality of the milk. Then the last point where the residues can enter, that is dairy residues. Actually, this is the important step. Actually, the residues may not enter, but the quality check is important for getting safe and nutritious milk to the human being. If there is no proper quality check, then or the testing is not there, monitoring is not there, in that case, the unsafe milk, or you can say milk with residues, uh, maybe you can say the sold to the consumers. So good practices at every step, they are required for safe and for supply of safe and residue free milk. Next slide, please. Next slide. Now, what are the causes of milk residues? Already we have discussed there are four causes of milk residues. In addition, I have added one more. But the how you can say the indiscriminate. What are the reasons for indiscriminate antibiotic use, which is leading to the milk residues? You all know that the high producing animals, they suffer a lot from various you can say the health elements, diseases, disorders, and the antibiotics. They are one of the component of the veterinary prescription. They are being used for the treatment. But many times, the farmers, they do the self-medication. They use the antibiotics on their way own without diagnosing the disease condition. I think this is the major reason for indiscriminate antibiotic use. Use of antibiotics by the farmers, by the paravets, or by the animal health, you can say the supporting staff. The another is a non-prescription use of antibiotics. Actually, the same. It is one of the same. So without prescription antibiotics, they are being sold by the, you can say, they are sold, and those are being used by the farmers and the paraprofessionals. Again, the treatment, sorry, previous one. The third important cause, the antibiotics, previous one, please. Third important cause is the overdose or underdosing. I will say mostly underdosing is responsible for, you can say, the indiscriminate use and antimicrobial resistance. Sometimes the prolonged treatment, even if treatment is not necessary, treatment with antibiotic is not necessary, but the antibiotics, they are used for a prolonged period uh, without doing a culture sensitivity or without doing antibiotic sensitivity. That is again a reason for emerging, you can say, the antimicrobial resistance. Even the doses, they are not being followed. Proper doses, they are not being given. Sometimes the proper dose interval is not being maintained. Incomplete course of the treatment is being sometimes done. So there are various reasons for you can say the irregular, irrational use of antibiotics. Apart from this, failure to observe the withdrawal periods. There is a milk withdrawal period for every antibiotic, maybe 72 hours, 92 hours after the last treatment. So milk actually is to be discarded during that withdrawal period. But that milk with antibiotic residues is being used. These are the various reasons for, you can say, the emerging antimicrobial resistance. The another, you can say, the important cause is the contaminated feed and fodder. How the feed and fodder gets contaminated. So feed and fodder, you can say, treated with a pesticide or sprayed with insecticide, pesticide, even with the herbicides, that may get contaminated. And such contaminated, see, these pesticides, they get access to the body, animal body, through such contaminated feed and fodder. Again, the improper storage of feed and fodder. So feed and fodder may not be contaminated with insecticide, pesticide, but if it is improperly stored, maybe at wet place, then fungal infestations may develop, fungal growth will occur, particularly aspergillus type of a fungus will grow, and that produces you can say the aflatoxin. Then the third important cause of milk residues is a hormonal misuse. Many of us know that the hormones, they are being used for milk dead down by farmers on their own without prescription. But nowadays, without prescription, there is now ban on the oxytocin. Without prescription, nobody is giving oxytocin. But earlier, this oxytocin was abundantly and easily available without medical prescription. And the farmers, they were indiscriminately using oxytocin for milk let down purpose in lactating animals. Again, many hormones, they are being used for, you can say, the management of the reproductive disorders. If required, actually, those are to be used. And hormonal treatment is the last resort. If animal doesn't respond to other treatments, in that case, only the hormonal treatment is, if it is being given. And the fourth cause is environmental pollution. This is common. See, industrialization increasing, urbanization is increasing, and you see, because of these things, the maybe these heavy metals, they are entering the food chain through the contaminated water, through the water feed and the grazing areas contaminated by industrial effluents. So that is another reason the heavy metals, they are being secreted through the milk. They usually bind with the milk proteins and they are secreted. And the last one is the improper dairy chemical use. You know that the chemicals, they are being used for cleaning and washing the milking utensils. If the milking utensils are not properly washed, then the residues of the disinfectants and detergents, they may remain, and they may contaminate the milk. Next slide, please. Health concerns. Actually, these milk residues, they affect both animal as well as human milk. They are affecting, and therefore they have got one health importance. How they affect the animal health? Usually the antibiotic resistance. So indiscriminate use of antibiotics leads to antibiotic resistance. And because of antibiotic resistance, the animals, they may not respond to the antibiotic treatment. They may either respond slowly or they may not respond to the treatment, and that leads to maybe sometimes a case fatality, and even delayed recovery, which is responsible for heavy economic losses to the dairy farmers or farmers. Second, particularly the continuous exposure of animals to the chemicals and toxins, that suppresses the immunity, that reduces the immunity of the animal. And whenever there is a reduction in the immunity, then such animals, they are prone to the various diseases. So there is increased incidence of the diseases. So the treatment cost will increase, and the disease will definitely affect the productive and reproductive performance. Third, reproductive disorders, actually hormonal misuse, particularly in the various reproductive diseases, that may lead to again a reproductive type of problems, endocrine type of disorders. The last one is the organ toxicity. The chemical contaminants, even heavy metals, chemical contaminants, aflatoxins particularly, they cause organ toxicity. Usually the liver and kidney dysfunction will develop. And whenever there is a liver and kidney dysfunction, the body metabolism is adversely affected, excretory mechanisms are affected, and usually that causes the suboptimal production, reproduction, and the overall performance of the animal. So these are the ill effects of, you can see, these heavy metals, toxins, and antibiotics on animal health. Here we are very, you see, and these, as far as these antibiotics residues are concerned, they are important from a human health point of view. And when the antibiotics, they are secreted through the milk as antibiotics, you can say, as a residues. So consumption of milk with antibiotic residues may lead to, again, similar type of problems as earlier discussed as far as the animal health is concerned. So this AMR from animals is being transferred to the humans. Many of the organisms, you can say they are shared. Many of the diseases, many of the organisms, they are shared by human beings and animals. So 75% of the organisms, they are shared by human beings as well as animals. So if the antimicrobial resistance develops in animals, the antimicrobial resistance will again develop in the human beings. So same thing that is being transferred to the human beings. And therefore, AMR is the biggest problem due to the antibiotic residues in the milk. Allergic reactions and hypersensitivity reactions, sometimes, maybe very occasionally, these things may happen. But allergic and hypersensitivity reactions to the antibiotic residues may develop in children's, human beings. Carcinogenic effects, those are very important. The feeding of a fungal infested feedstuffs, pesticide residues, continuous ingestion of the pesticide residues may lead to carcinogenic effects, may lead to carcinomas, may lead to cancer. So because of pesticide residues and the aflatoxins, the cancer may develop in a human being. Cancer patients may increase. Then the last one is the hormonal imbalance. Hormonal residues may interfere with the endocrine functions in human beings too. But this is a least common cause. Among all these ill effects, in my opinion, the first AMR is you can say, the worst problem resulting from these antibiotic residues, and second, carcinogenic effects. Next slide, please. So see what happens due to the residue-free milk. What is the economic significance from farmer or industry point of view? So residue, wherever this residue-free milk is very important. So presence of residues in the milk or milk with residues is responsible for reducing the reducing the confidence of the consumers. If we can provide the residue-free milk, then the consumers' confidence will increase. And definitely, you can see the market price will be increased. Market price for a milk will be. The residue-free milk is important. If you want to export the milk, then it should be a residue-free milk, or residues should be within the limits, advised by, you can say, FSSI. Only that milk can be exported. If we want to increase the export of the milk and milk products, then it should be made residue-free. If it is a residue-free, then it will not be rejected by dairies. Now, some dairies, they are coming forward, dairy industries, they are coming forward for collecting the residue-free milk. And in future, definitely, every dairy will go for collection of the milk, residue-free milk. And such type of the facilities will be created by the dairies. So if it is a residue-free milk, then there will not be a rejection. Then residue-free milk will get a premium price. If it's a good quality milk, you see the people, they will give a good price to the you can say, the milk. So ultimately, our farmers will be benefited from producing the residue-free milk. So residue-free milk is important for a sustainable, you can say, it will result in a sustainable dairy farming or a scientific dairy farming. Next slide. Next slide. So we already discussed the challenges. Now, challenges to overcome. Actually, the low farmer awareness is one of the challenge. There is you can say, lack of knowledge about drug residues and their impact on health and milk safety. So this is the important point. Low farmers awareness. Another is the easy access to the drugs. Veterinary drugs, even today, the farmers, the paraprofessionals, they have got easy access to the drugs. So over-the-counter availability of antibiotics and hormones without proper prescription. Then third is inadequate veterinary services. The paraprofessionals, farmers, they are treating their patients on their own. They are bringing the drugs without prescription. One of the reason is a limited access to veterinarians for proper diagnosis, treatment, and withdrawal advice because of inadequate, you can say, the veterinary services. There are limited number of veterinarians, so that is one of the reason for, you can say, such type of the practices. Weak monitoring system. Actually, this is the another reason why such type of, we can say, milk with the residues is being sold, because tests for, you can say, residues such as antibiotics, hormones, and pesticides, they're not being done because of, especially because of insufficient testing infrastructure and irregular monitoring for drug residues in milk. So this is another challenge for us. And then the fifth is feed quality issues. Use of contaminated or poor quality feed leading to residues and toxin in the milk. So quality, there is need to provide a quality, you can say, the feed. Then the smallholder dominance. In our country, actually large number of small scale farmers, they are producing the milk, and they are unaware of, you can say, the importance of producing the residue free milk. And even it is difficult to, if suppose there are large number of the farmers, then they're difficult to train them, difficult to create awareness amongst them. So overcoming these challenges is the key. These are the challenges, and overcoming these challenges is the key to ensuring a safe, high quality residue free milk for a healthier India. Next slide, please. Future strategies. What should be the future strategies for getting the residue-free milk? Rational drug use. So promote judicious use of veterinary medicines and antibiotics. Discourage farmers, paravets, paraprofessionals not to use the antibiotics without the prescription of, you can say, the veterinarian. So there should be a rational drug use. This is very important. Strict withdrawal period. In India, this withdrawal periods are not being followed. There is little awareness or no awareness amongst the farmers, and even many learned peoples, they do not know the withdrawal periods to be followed for the antibiotics and even various drugs. So follow recommended withdrawal periods to ensure residue-free milk. Most of the antibiotics, they are secreted through milk for 72 hours after the administration of the last dose of the drug. And therefore, 72 to 96 hours is usually a withdrawal period. Good animal husbandry practices, GHP, or good dairy farming practices, they need to be adopted, such as hygiene. You see the hygiene, proper animal care, clean housing, and ethical farming practices. There is need to expand and strengthen the milk testing infrastructure for accurate and timely results. Then again, ensure the quality feed and fodder free from contaminants and toxins. And for this, actually, there is need to create awareness among the farmers about a proper storage of feed and fodder. If the feed and fodder is properly stored, then usually these fungal toxicosis can be avoided. Then farmer education programs, on a larger scale, they are to be undertaken. They must be undertaken to increase the awareness and of the awareness among the farmers about the, you can say, the safe practices, clean milk production, and hygienic practices on the farm. A robust regulatory policy. So strengthen policy enforcement, monitoring, and legal framework for food safety. This part was being neglected, and therefore many times this adulteration and you can say the milk with the residues is being sold in the market. Poor quality milk is being sold. So there is need to have a robust regulatory policy. One Health approach is very important for, you can say, preventing the milk residue-free milk. Integrate animal, human, and environmental health. And actually, here veterinarians they can play a major role help for a sustainable dairy farming system. Next slide, please. Next and last. The veterinarian's role. The veterinarian has to play a key role in, you can say, the prevention of this residues in the milk, or for producing and for providing a residue-free milk. So a rational drug prescription is required. So veterinarian has to prescribe required drug based on antibiotic sensitivity specific to that disease, and then again a full course of treatment with a proper dose. That is what required. Again, the antibiotic use in case of viral diseases is unwarranted, not required, and that has to be discouraged. Then second is the disease prevention. The veterinarian has to give this thrust on a disease prevention rather than a disease treatment, because disease treatment is responsible for milk residues. If disease prevention measures they are being taken, we can reduce the you can see the abuse of the drugs, uses of the drugs. So disease preventive measures and preventive healthcare, that is proper deworming, proper, you can say, the control of ticks, and even the vaccination, that will help us. Here again, I would like to share, for again control of the ectoparasites in in animals, usually insecticides, pesticides like cypermethrin, deltamethrin, and various, you can say, the pesticides they are being used, insecticides they are being used. Their use has to be minimized. Their use is, you can say, is to be minimized. And how? By using, you can say, the biological control methods. Biological control methods, they work very nicely. Even simple use of, you can say, the use of ethno-veterinary medicine practices, fly repellent type of the drugs, neem oil, karanj oil. So with the use of these drugs, we can reduce the use. So we have to reduce the use of insecticide, pesticides for ectoparasites. I will tell you, and I would like to share, that we can control the ectoparasites with herbal treatment as well as the biological treatment to the greatest extent. Again, by vaccinating the animal at proper time, you can say we can prevent the infectious diseases and we can reduce the antibiotic use. And as far as the dewormers are concerned, the chemical dewormers are rampantly used for the treatment of animals. Actually, those are not required. In old days, we are advising the deworming schedule for the animals. Give dewormers before monsoon, after monsoon, thrice a year, after parturition. You see, this is required only for grazing animals. When the animals are stall fit, when animals are kept in a loose house, they rarely need dewormer. They rarely need a dewormer. And dewormer is to be given based on the results of the fecal examination, and that practice has to be made in order to reduce the use of, you can say, use of dewormers. So the use of dewormer has to be minimized. Again, herbal dewormers, they have they are available in the market. So I can I can suggest that dewormers either use herbal dewormers and improve the management practices on the farm so that the chemical dewormers use can be minimized. So we can discourage the use of dewormers. We can discourage the use of chemical type of pesticides. And again, when we are the fodder is there. As for the fodder, proper storage of the fodder, proper storage of the corn or feedstuffs or feed ingredient. If they are properly stored, then fungal you can say fungal growth will not occur, fungal toxins will not develop. And now there is a need to incorporate the toxin binders in the feedstuffs that will help in preventing the aflatoxin related problems in the you can say animals as well as the human beings. And monitoring of the withdrawal period, now we'll have to educate the farmer to discard the milk for at least 3 days after the after giving the last dose of antibiotic treatment. So in my opinion, that farmer education, awareness of the farmer is the most important for you can say for preventing the residues in the milk, encouraging the residue-free milk for residue-free milk. And definitely that residue-free milk will fetch a higher price in the market, and that milk can be very well exported. So with this, I will conclude. Last slide. Last slide. This is the take-home message: ensuring the residue-free milk ensuring residue-free milk protects public health, sustains dairy livelihoods, and secures India's place in the global trade. Unless and until we increase the export of milk and milk product, our farmers will not get a good price. So a coordinated approach between coordination is required. One person cannot stop this, you can say, things. And for this, a coordinated approach between farmers, veterinarians, industry, and policymakers built on farmers' awareness, rational drug use, strict withdrawal periods, and strong monitoring systems. This is very important again, strong monitoring system. So that will help. A residue-free milk, the future benchmark of quality, sustainability, and consumer trust. With this, I conclude my lecture. Thank you.
Thank you very much, sir, for your nice presentation. Friends, today, in a very first lecture, Dr. Bikane sir has already told us about how to produce the residue-free milk and what are the challenges to produce the residue-free milk and the strategies to achieve that things. Now, this topic is open for discussion. If anyone has any queries, feel free to ask to Bikane sir regarding the residue-free milk production. Sir, first of all, I have one question to you. Sir, as far as the fruits and vegetables and other grains production is concerned, when we are using some sort of pesticides, there is a label claim on that particular pesticides for PHI, that is pre-harvest interval, which is assigned by the CIBRC. But as far as a fodder crop is concerned, such type of label claim is not observed. And as far as in the context of the Indian farmer is concerned, our farmers are not taking due care to manage the pest and diseases on the fodder crop, and they are currently using the pesticides on the fodder crops. And in your lecture, you told about this thing that this type of practices may lead to the adulteration in the milk of these pesticides. So, what will be the strategy needs to be done to avoid this type of practices so that we can avoid the pesticide residue in the milk?
In case of the animals, see the fodder crops, especially cultivated fodder crops, they are being fed, especially the green fodder, they are being green fodder varieties. And as far as the dry fodder is concerned, usually it's agriculture, you can say byproduct residues. They are
Yeah.
maybe arbusa or paddy straw or whatever it may be. I've seen whenever pesticides they are being sprayed repeatedly. Especially, I have seen it in case of the turbusa or ararbusa that is being fed to the animal. If it is being continuously fed to the animal, in that case, even a cumulative type of poisoning develop. Type of poisoning. So there are two different sources. You have raised one very important point, and I think we'll have to work on that. And even we can give that type of recommendation to the you can say fodder seed manufacturing companies about these type of the labels that advice needs to be given. But I'm also, you can say, worried about the soybean straw. If it is being sprayed, it is somewhat less common, but even soybean, which is being treated with pesticides many times, and in that case also the whatever soybean straw is being fed to the animal, and if it is continuously fed, that too in a more quantity or exclusive feeding is there, animals may exhibit the signs of chlorinated hydrocarbon poisoning, particularly, the organochlorines, they have got a cumulative type of effect. These insecticides, they are stored in the adipose tissue, and once they reach the toxic levels, then the signs of poisoning occur. And even if in a small quantity, they may be released, and along with the milk fat, they enter in the milk as a milk residues. So these are the two different problems. And third one is the fungal toxins. Again, the good management and good storage of a fodder, particularly storing fodder at a dry place, and adding, you can say, the toxin binders in a feeds, particularly compound type of the feeds, may solve that type of the problem. But as far as this dry fodders are concerned, in my opinion, and especially legume straws, which are exposed to these pesticides, they are one of the major problem as far as the milk residues. That's my practical experience as a physician. Just I'm saying.
Well, thank you, sir. Sir, there is one question in the chat box that how normal consumers can ensure the milk they buy is residue free. Is there any easy way to detect the milk is residue free or not?
So I think it's difficult for a one monitoring is a very important, and then labeling is important. Labeling, monitoring, and labeling, testing and labeling. That will develop the trust. That will develop the trust.
Is anyone has the questions to ask? So it seems that there is no question. Then we will going to stop here. Sir, today we have eminent scientist with us to deliver the lecture on ensuring a residue-free milk challenges, health concerns, and the future strategies. Dr. Anil Bikani, sir. Sir, I am very thankful to you for sparing your valuable time for this national seminar as a lead presenter. Very thank you, sir.
Thank you. Thank you for giving
Thank
me the opportunity for
Thank
a
you, sir.
lead paper presentation. Thank you.
Thank you.
And all the best.
Now, our next speaker is Dr. Shantal Kumar Mukhne sir and Dr. Vishnu Zaune sir. And the topic is application of IVF technologies at field level for genetic improvement and conservation.
Hello.
Welcome, Dr. Shantal Kumar and Dr. Vishnu sir for the topic application of IVF technologies. Sir, please share your PPT. Hello, sir. Are you there?
Yes,
Ah,
yes, yes. I'm sharing. Hello. Am I audible?
sir, you are audible, but your sharing has been stopped.
Okay, okay, okay. Yes. Just I'm sharing. Is my screen is visible?
Are visible. Make it as a PowerPoint presentation, sir.
Yes,
Full.
yes,
I,
yes, yes.
yes, is looking.
Okay, okay, okay. So, good morning, all of you. And firstly, I'm sharing my gratitude towards the Ajit Pawar Indigenous Cattle and Research and Training Center for allowing us to share our lead paper presentation. And I'm sharing this presentation on the behalf of our visionary CEO, Dr. Sital Kumar Mukne sir. So my topic is application of ETIF technology for genetic improvement and conservation of indigenous cattle breeds in Maharashtra. So myself, Dr. Vishnu Zavne, and I'm a state nodal officer for the embryo transfer in vitro fertilization lab of the government of Maharashtra. So my presentation outline is like a need for ETIF technology, government initiative, workflow, infrastructure, achievements of this technology, research topics, and schemes of government for the for embryo transfer technology and future roadmap. So as we know that we are having a huge indigenous germplasm, that is like cattle breeds in our India is 55 and buffalo breeds are in India is 22. Out of that, our Maharashtra having the 7 cattle breeds and 5 buffalo breeds which are registered in NBGR. That breeds are like Dangi, Devni, Lal Kandhar, Kathani, Gaulau, and of course Kokan Kapila and Khila. In Buffalo, we are having 5 distinct breeds which are registered in the NPGR, that is Pandharpuri, Melghati, Purnathadi, Nagpuri, and Marathwada. These all breeds we have to conserve and multiply. For that, MLDB already initiated the projects. That is pedigree selection PS project under MLDB. That is first project is a PS Pandharpuri project, and another is a PS Gaudaur project. They we have got very good results from the PS Pandharpuri project. That now we are increasing our MSP. Like before, it is about 1300 to 1600 for Pandharpuri. Now it has been increased up to the 1800 to 2200, and we are getting the some good buffaloes which are having the lactation yield about 3400, which are recorded on NDLM data. Also, we have started the another project under the MLDB, that is a PS Gaulau project. So we have started the field recording of these Gaulau cattle As well as in that project, we have also included the Nagpuri buffalo for recording. So we initiated this project for improving the indigenous breed through our pedigree selection project. As we know that as conventional breeding limitations of AI, that for improvement of any indigenous breed, that we need a lot of generation, that is up to the 7th generation. The one generation is account for the 3.5 year. So any nondescript animal giving the birth of pure birth, it require about 21 to 24 years. And due to this slow process of genetic improvement through AI, we need the advanced technologies like embryo transfer and in vitro fertilization. In this technology, we know that we are having a high genetic merit donor, and using the high genetic merits bull sire semen, we are producing the embryo, and that embryo are implanted in the nondescript animal for the as a surrogate mother. We can use the nondescript animal as a surrogate mother, and directly we can achieve the calf which are having a high genetic merit value in a one generation. So the period of 24 years is directly shortened up to the 3 years. That is the beauty of this technology. That is we call that is embryo transfer and in vitro fertilization. So as we know that the generation interval is also reduced, as well as we can multiply the high genetic merit cows in a very faster way. That in a natural condition through natural breeding, through the high genetic merit cow, we can get only one calf per year. Through AI also, we can get only one calf in a year. Through the MOET, that is multiple ovulation and embryo transfer technology, we can get the 12 to 15 calf through this high genetic merit cows. But through the advanced technology like the embryo transfer and in vitro fertilization, we can get up to the 50 to 75 calf per year from a single cow. That is, we can multiply the high genetic merits cow in a very short period, in a very huge quantity. So this is the advantage of this technology. We can see the summarized flow diagram, how this technology works. Like start from selection of donor, then ovum pickup process, then this ovum will be matured for 22 to 24 hours in a laboratory. Then after the maturation, we fertilize them with a high genetic merit sire semen, and after fertilization, we kept for the development up to the expanded blastocyst level in a laboratory, in a specialized incubator called benchtop incubator for 7 days. And after this 7 days, we can collect it embryo, filled in the straw, like a AI straw, and transfer it on the surrogate mother. Otherwise, if we don't have any surrogate mother, we can freeze that embryo and keep for a longer period in a liquid nitrogen at the minus 196 degrees Celsius. I have a short video, in 2 minutes video, that we can get the clear idea about how this process takes place. That by selecting the donor, we can keep or restrict in our chute. Then this suction pump is attached to the accessories, and this sonography machine gives us a clear idea about the follicles present on the ovary. After seeing these follicles, we can insert the gun having a tube attached at the end of pipe, and a needle. Every follicles we can aspirate through this needle. We are seeing the video with aspiration video, that every follicle is collecting by this aspiration. This collected follicle will be in this test tube, and this test tube is transferred in our laboratory. So after reaching the test tube, we can separate the fluid from these follicles with our strainer, and these all the oocytes we are searching under the microscope. We can get this good quality of oocytes. Then we can mature it in an incubator called a benchtop incubator for 20 to 22 hours. After maturation, we can get the expanded oocytes. Then these oocytes we have to fertilize, and before fertilization, we can check the sperm count or sperm motility of the sire. And for after the motility, we can decide the quantity required for the fertilization of that particular oocytes and deposit this semen in the dish which having this mature oocytes. After deposition of sperm, the sperm will get attached into the oocytes and allowing the oocyte to circulate in a anti-clockwise rotation. Within a 15 to 16 hours, these sperms are enter through the zona pellucida and start the fertilization process after the 16 hours. Then 2 cells, 4 cells, this multiplication start, and this embryo we can keep in an incubator for 7 days. On 7 days, we can get the blastocyst or expanded blastocyst level for embryo transfer. Then this type of embryo we can collect, filled in the straw, and we can transfer this embryo in a recipient couch. So this is the flow chart, or otherwise we can store this embryo for a longer period. So this is the flow diagram for this embryo transfer technology. And we have started this laboratory, that our government of Maharashtra started this laboratory through DPDC fund in 2017 and 18. That is 1.98 crore fund received from the DPDC fund Pune. And initially, two lifestyle development officer were deputed for the this technology in March 2021. And we have started this laboratory in very minimum infrastructure, so to minimize the cost of embryo production. Now, through this from this result of this laboratory, the government has sanctioned our 6 new laboratories, which are started in every region of our Maharashtra. That is in a Konkan region. We have in a Raigad, our laboratory, and Raigad. In a Tathode, Pune, that is in a Pune region, our laboratory is in at Tathode. That is, I am working there. And third laboratory is in our Nashik region at Ahilanagar Loni, near to the Sherdi. Our fourth laboratory at Chhatrapati Sambhajinagar, that is Harsul. Our fifth laboratory is at Akola, near the Segav. And our sixth laboratory is in Wardha district, that is in Hetikundi, where our Gaudav farm is there. So these 6 laboratories now going to start within a few days. So after receiving the good result of this technology, we extended this network of our embryo transfer laboratory throughout our Maharashtra. So we allotted the every breed, that we know that we are having the 7 cattle breed and 5 that is a buffalo breed. So we wanted to accelerate the genetic improvement through this embryo transfer technology in our farm. So every IVF laboratory has allocated with the particular breed, that is the pen in a Konkan region having a breeds, that is allotted breeds are Konkan Kapila, Mehsana buffalo, Mura buffalo, Jersey crossbreed animals. Like Tathode Pune has allotted with the Khilar, Pandharpuri buffalo, Jersey, Sahiwal, and HF crossbreed. Chhatrapati Sambhajinagar allotted with the Devni, Lal Kandhari, Marathwadi buffalo, Jersey, and HF crossbreed animals. Then Loni from Ahilanagar, we have allotted them the HF pure, HF crossbreed, Jersey crossbreed, Dangi cattle, and Mura buffalo. In Gaudao, in Akola, we allotted the Gaudao, Purnathadi buffalo, Jersey, and HF cross. And in Hetakundi, we have allotted the Nagpuri buffalo, Sahiwal cattle, and Kathani breed. So these all the laboratories are allotted a particular breed for the genetic improvement, and through generate the to develop the embryo from the that indigenous cow. Along with this, MLDB has a public sector model for embryo transfer in a field condition. Like we have already received the 3 projects. Like first project is with Vidarbha Marathwada Dairy Development Project, that we are going to supply the 7-month pregnant heifers impregnated through the high genetic immunity embryos to the farmers selected under the Vidarbha Marathwada Dairy Development Project. Then our second project is that for establishing the bovine IVF pregnancy in HF cross animals in the Satara district. And our third project is with the collaboration with the Ajit Pawar Indigenous Cattle Research and Training Center, that is the embryo transfer in recipient cows at API ICRTC farms and farmers doorstep nearby the Pune. Then Mukhyamantri Gramin Pashudan Udyojakta Yojana. Recently, our state government has launched these schemes. In that scheme, we are providing the 100% subsidy to the selected farmers for confirmed pregnancy by impregnated with the high genetic merit embryo. So this initiative have taken from this state government for promoting the embryo transfer technology at a field condition. We can see the all the our MOEs in presence of our Honorable CM Devendra Fadnavis Sahib, then our Cabinet Minister Pankajatai Munde sir, and our Honorable Secretary sir Ramaswamy sir, our CEO sir Dr. Mugni sir, along with the Chief Scientist Dr. Somnath Mane sir, our DDC Satara, and Honorable MLA Dhananjay Munde sahib. The primary aim of the MOU of MLDB with VMDDP is to supply the 7-month pregnant cows impregnated with the high genetic immunity embryo to the farmers, and also we can evaluate the field performance of calf-born through the ETIF technology under the field condition. Also, we are going to maintain the performance and progress record of that IVF calf, and the selection of donors and embryo production breed is choice is given to the farmers, to that respective farmers which they wanted the embryo of for their recipient cows. Our another project is with the Jilla Parishad Satara. In that, we are going to establish the confirmed bovine IVF embryo pregnancies in a high fidelity crossbreed as well as ND animals belonging to the selected dairy farmers in the Satara district, where 90% subsidy of the confirmed pregnancy cost will be given to the farmers by the Jilla Parishad Satara, and 10% cost and logistic will be borne by that farmers. The selection of donors and embryo will be as per the choice of that farmers. Our third and most important project is with Ajit Pawar Indigenous Cattle Research and Training Center for to establish the confirmed indigenous bovine IVF embryo pregnancies in a crossbreed and animal belonging to the selected dairy farmers having the reproductively efficient crossbreed and animals within the 50 km from the Pune for the selection of the ET. And also MLDB charge per confirmed pregnancy impregnated with a high genetic merit indigenous embryo at the farmer's doorstep and also at the Goshala Government Institute. And also another topic, that is supply of 3-month pregnant heifers to the institute with a high genetic immunity indigenous embryo. Also supply of indigenous calves born through this high genetic immunity embryos. And all the financial support will be given by this institute, that is Ajit Pawar Indigenous Cattle Rearing and Training Center, for the development of high genetic merit cows at a field condition at the farmer doorstep, and also to develop the genetic improvement project in a field condition. So this is the very important project that we are collaboratively running in a field condition. That already the work is going on about 35 embryo transfer done in a last month from this project nearby this Pune district and near the Tehsil, that the animals selected from the farmers and embryo developed at the IVF laboratory in our Tathode, and we are going to transfer this embryo at the farmer's doorstep. Our another project is that is the Mukhyamantri Gramin Pashudan Udyojakta Yojana, which is launched in this year. That their provision is to establish the confirmed bovine IVF embryo pregnancies in a selected dairy farmers having a reproductively efficient crossbred and non-descript animals from the Maharashtra. In that, we also evaluate the field performance of the calf born through this technology under the field condition. Also, the scheme will be implemented through newly established ETIF laboratories in a coordination with the respective DDCH office, and 100% subsidy given to the beneficiaries from the confirmed pregnancy. So recently, this scheme is launched in our state, and by the start of this scheme, we can provide the 100% subsidy for confirmed pregnancy to the dairy farmers. Then, with the financial support through these different schemes of ETIF laboratory, MLDB plan to transform its government bovine breeding farm by implementing progeny testing project and selective selection of various breeds with the use of this technology. That we know that MLDB already having the 9 government bovine breeding farm. That is one is at Vadsa, where we can improve the breed, that is Kathani, Sahiwal, and Sahiwal into Jersey cross. Then at Hetikundi, at Varda, we are going to improve the Gaulau, the strains of Gaulau and Nagpuri buffalo. In government bovine breeding from Pohra near the Amravati, we develop their Gaulau and Gaulau with Tharparkar cross. The government bovine breeding farm Hingoli, we are developing their Mura and Marathwadi buffalo. Then in a Kopargaon government bovine breeding farm, that HF cross animals gear into HF cross, HF 100% animal, 100% animals, and Dangi breed. Then in a Tathode farm, we are developing the Darshi breed, Pandharpuri buffalo, and strains of the Pandharpuri buffalo. Then in a Junoni, that is government bovine breeding from Junoni, we are developing the Khilar breed and its strains. In Zat farm, we are going to develop the Gir high genetic breed Gir cows, Brazilian Gir strains, and Gir into Jersey cross. And in a Sakud, in a newly formed farm near the Bid, we are developing the Devni and Nalkandari breed. So all the breeds we are going to cover through the indigenous breeds of the Maharashtra, and we have started this project in our farm. Initially, we are having 100 recipient animal on each farm for the embryo transfer, and after the calf born, we are going to develop this calf after pregnancy, where we have planned to record the milk up to the third lactation, and after the development of this breed, we can also transfer this selected donor for the embryo transfer lab. Through this project, our outcome is that 100 animals from each JBV will animals are included in the project. That is 100 recipient animals will be included in this project. The 585 high genetic meat animal will be available for every government bovine breeding for selective selection as a parent stock. The 300 pregnant heifers will be supplied to the Vidarbha Marathwada dairy development farmers with genomic breeding value, and 150 pregnant heifers cow will be available in MLDB for supply to the different projects like milk breed supply, and that is 100 more than 100 high genetic breed male cows of the various breed known source and record will be available for supply to semen station for the development of semen station. Then 100 more than 100 high genetic merit cows of various breed and known source and record will be available for sale to the farmers. So this will be our projected work for next 5 years, that through this technology we are going to develop each and every breed of our Maharashtra, indigenous breed of our Maharashtra, and parallelly we are starting the progeny testing scheme or progeny testing project through this technology. Our embryo transfer laboratory is also center of excellence for research and human resource development. Having an academic contribution that we have already completed the 9 postgraduate research paper or research thesis in our this ITIF laboratory Tathawade. That from 2020 to 21 we have completed the thesis on a different topics related to the IVF. So to develop the many research or standardization through this technology. So scientific achievement of our government laboratory is like a standardization of home pickup protocol. Then successful embryo production from indigenous breeds like Khila, Tharparkar, Gir, Sahiwal, Holstein Friesian, Darshi, Pandharpuri, and Murrah Buffalo. Also successfully production of the Gir, second generation Brazilian Gir, Sahiwal, HF, Darshi, crossbreed, and IVF calves. Also, the birth of the first Pandharpuri buffalo IVF calf, that is Sital, representing the landmark achievement of buffalo reproductive biotechnology. And field embryo transfer under government condition. We have started the embryo transfer in a field condition since last 3 years. Also, we have confirmed the doorstep pregnancy at the farmer's doorstep. So this is our first Pandharpuri buffalo calf, IVF calf, that is Sital. Our team and field condition for OPO and also collecting the oocytes from the high genetic merit cows from the farmer's house as well as in a different institute. So we can collect the oocyte from the field and develop it in our laboratory. And after formation of the embryos, we can collect the embryo and transfer it in a farmer doorstep. The impact of this technology on a farmer is very much interested. That is very much having the economic benefit, like having a high genetic merit cows, increase milk production by having the high genetic merit cows. Then faster herd improvement, that we can improve the herd in a very minimum period of time. That we already seen that for conventional method it can take about 24 years to improve their genetics, but through this technology we can improve this herd within 3 to 4 years. Then reduce the generation interval, that we know that for the progeny testing period we can require 8 to 9 years to select the proper sire, but through this technology we can reduce the generation interval very short period, that we can collect the OHA from the 9 to 10 month IFPR also, and up to the age of 15 to 17 months we are having the calf of that animals. So generation interval, that is about 3 to 3.5 years, that is 3.5 years, we can reduce it to the 1.5 years through this technology. Then better disease resistance, that we have we are already screening all the animals before embryo transfer and before collecting the home pickup, that is for the sexually transmitted diseases like brucella, IBR, and through this we can better the disease resistance also. Improve the reproductive efficiency through this technology. Now we are improving the reproductive efficiency by doing different protocols for the estrus synchronization, where we can minimize the generation, intercalving period up to the 12 to 13 months by use of this different protocol for synchronization of Easter. Also, through this, all the facilities were going to increase the farmer's income in a minimum times by allowing them to give the animals with a high production milk. Our future roadmap, that is our government Maharashtra, imagine the expansion of ETI services to all district. Yes. Am I audible? Hello.
Yes, sir, you are audible. Participants,
Okay.
please mute yourself.
Okay. So our future plan of government Maharashtra is the expansion of ETF services in all districts. For this, we are going to train our veterinary officer from the every district and every tehsil to circulate this technology at a field condition. And every tehsil, our embryo transfer technician or expert will be there for the embryo transfer. Then genomic selection of the donor animals. As I have mentioned that we have already initiated the PT project in our dairy farm, where we are sending the samples for the genomic selection or genomic breeding value, and the best donors will be selected on the basis of genomic breeding value for the future breeding purpose. The integration with the sex-sorted semen technology, we are using the sex-sorted semen for the development of embryo. So we already the transferring embryo with the sex-sorted semen, so that we can get the more than 90% female at a farmer doorstep. Also, the remaining the 10% male will also be used for the for this semen station, which are having the high genetic merit calves, male calves. The production of indigenous breeding bulls will be initiated through this project and through this technology. That we know that we are having a very low numbers of the indigenous bulls, and many breeds like Marathwadi, Kathani, Kokan Kapila, they are not having the recorded bulls still now. So we are also having the planning to get this bull as soon as possible through the recorded through this project. Then development of nucleus hearts, that our every government buoyant breeding farm will also develop into the nucleus hearts of that breed, and that all the research will be taken on that farm for this particular breeds, like selection of the trace and many things we can develop through this nucleus hearts. Then export the quality indigenous germ farm. We are also planning to export our quality indigenous germ farm to the another countries. Then conservation of the threatened breeds, the breeds which are in extension, we are going to conserve through this technology, like embryo transfer technology. Also, we developed the gene bank for our indigenous breed, where we can keep the semen, oha, and embryo of all these breeds for the future use. Also, our planning is to establishment of the Maharashtra as India's leading state in a bovine reproductive biotechnology. So all the indigenous breeds of cattle and buffalo will be developed in future. So this is my very short presentation. Thank you for your kind attention, and we can take the questions if any. Thank you.
Thank you, sir, for a very nice presentation. Sir, I have one in-depth knowledge about the embryo transfer technology and different schemes and new technology regarding genetic improvement. If there are questions, participants, please ask your questions. Sir, there is a question from the chat box. Is it possible to achieve complete genetic improvement through IVF technology? That is a question from the one participants.
Yes, yes, definitely. We can achieve the genetic improvement through the technology, but along with this technology, we have to start the progeny testing project also, because every crop getting from the high genetic merit dams and sire will not be having a same merit. So through this IVF technology, we can get the multiple cups from minimum donors. But for the improvement, we have to start the progeny testing program also.
Okay, thank you, sir. If there is a question from the participants, students,
Yeah, hello.
farmers,
Hello.
yes,
Yes.
please. Yes,
Yeah,
Pritam, sir, please.
my bull's GBB is around 751, yeah, 752. So I have many calves of this bull. Can I use the bull with GBB of around 550, 560, whichever available with NDDB, SAG nowadays? Can I use
Which
that bull?
breed, sir? Which breed bull is there?
Gir.
Gear bull. Okay.
Yeah.
So you are having a 750 GBV bulls.
751 or 752, I don't remember exactly. But
Okay.
then
Okay.
normally the Simon available in Rahuri and many other Simon station, their
Okay.
bulls are around having a GBB around 550, 530. Some say some are even less than 400. So what will
Okay.
be the impact? What will be the impact on progeny? What I will be getting in future?
Okay. Actually, your bulls having a genetic merit that is 751 means you are having the production record up to the 4,700 to 5,000,
Mhm.
because after 600 GBV, the record will be as per NDDB record, that is above 4,500. So
Mhm.
many institutes are having the minimum GBV record at 500, 600, but they are having the milk record up above 5,000
Okay.
milk record.
Is this
So
5,000 in 305 days or the entire lactation yield?
that is 305 days.
305 days. Okay.
Yeah.
Okay.
So
Yeah.
you can select the bulls on the basis of that milk record also, because the genomic breeding value very having a very different value from state to state.
Okay. So
So
I have checked my GBB in Anand with Doctor, I think
yeah,
Nilesh
yes.
Naini.
Now there is the only one institute in our
Okay.
India, that
Okay.
is
In
the
India. Yes.
ha.
Yes. Hmm.
So nowadays, if you are not getting the genetic GPU above the 750, so you
Yes.
can simply select the bulls on the basis of the milk record.
Okay.
Also, the 500 to 600 GPU is good for your hippers to
Okay.
for the insemination. So you can
Okay.
select from that bull also.
Okay. Seeing mother's yield. Okay.
Yeah.
Okay.
Yes.
Okay. Thank you.
If there is any another questions from the participants, students, participants, farmers, you can ask the question.
Good morning, sir.
Good morning.
Sir, myself, Dr. Akkare, Associate College of Agriculture, Moon. Sir, is it feasible this technology at the doors of farmers' field?
Sir, please repeat your question.
This technology, is it feasible at the doorstep at the farmers' field?
Okay. Now we are transferring the embryo at the doorstep from last 3 years. Actually, it is very critical to reach at the farmer's doorstep and selecting the recipient from the farmers. But as we are not transferring the embryo at the field condition, then we are not getting the exact results. And fresh transfer is very critical at the farmer's doorstep, but we are developing the frozen embryo for the embryo transfer at a field condition. Nowadays, we are getting the 15 to 20% conception rate. After getting the conception rate about 25%, we are transferring this frozen embryo at a field condition. So that will be more easy than this fresh embryo transfer. But for the development of this technology, we have to go on a field condition for better to getting the better result.
Sir, there is how much cow needs to be at the level of farmers cattle house?
Yeah. Actually,
How much cow requires?
Yes. Actually, the farmers having a 10 breedable population, meaning 10 reproductively efficient animals. We are going to select that farmers because we are transferring our embryos in a hippers first or second lactation animals only.
Sir, this is the
Also,
major constraint, sir. Sir, this is the
Yeah.
major constraint
yes.
because only 2 to 3 animals kept by the cattle owners.
Yeah. So now we have to select the farmers having a large cattle population, like a big farmers which are having a 25, 30 or 50 animals. And after selecting the 10 animals, we have to synchronize them. After synchronization, only 6 to 7 animals are developed the CL for embryo transfer. And after transferring the 7 embryo in that 7 cattle, we are getting the 3 to 4 pregnancies. So this is the ratio for conception rate. So for the confirmed pregnancy of 2 to 3 animals, we have to transfer the embryo in 8 to 10 animals. So nowadays we are selecting the farmers having the more than 25 to 30 animals, where we can get the 10 reproductively efficient animals for the embryo transfer.
Sir, our department work with the MAPSU sir, Dr. Manoj Patil,
Yes.
cooperate to implement this technology at our farm. Dairy
Yes.
farm, animal husbandry and dairy science section, College of Agriculture, Nagpur, sir.
Okay.
During last 3 years.
Yes.
And now,
And another thing that I want to mention that for the recipient animal, crossbreed animal and ND animal is good. That is indigenous animals like Gir, Sahiwal, then the Gaulau and Kokan Kapila. They are least important because we know that the synchronization protocol should be followed for these animals, and the animals should be docile and having the proper BCR. So we have to select the crossbreed and nondescript animal for as a recipient is a good choice.
Yes, sir. Yes.
So one more question,
Thank you,
sir.
sir. Thank you.
So one
Yes.
more question. Can I
Yeah.
ask? Yeah.
Yes.
So what is the percentage of stillbirth in this IVF technology? Because I've seen many cows giving stillbirth in Gujarat. So
Yes.
is it? Yeah.
Actually, stillbirth is another problem. There is a genetic role also played. Like I am also having a one donor where I observed that many stillbirth because the compatibility of embryo then recipient will be more required. So particular donor will be responsible for the stillbirth. Now I'm saying about the 3 to 5% stillbirth after conception or abortions in the last trimester also we have observed abortion from 45 days to the ninth month. We have observed 3 to 5% or more than 5% in some cases were observed. But that is up to the particular donor can be responsible for that, and up to 5% stillbirth and abortion are the normal in through this technology.
So it is related to, it is genetic, it is not related to technology.
Up to 5% it is related to the technology, and above 5% will be related to
Genetic,
the
okay.
donor. Yeah,
Okay.
as I observed.
Okay. Thank you. Thank you.
Thank you, sir. If there is any questions from the participants, students? It seems there is no questions. Thank you, sir. Today's for this lecture, Dr. Vishnu Zaune sir from the Maharashtra Livestock Development Board, Nagpur. He is an expert in IVF and embryo transfer technology. He has given a very good lecture on the genetic improvement by that MLDB. So all the participants are get benefited from that lecture. Thank you, sir, from our project.
Yes, thank you very much for participating. Thank you.
Thank you, sir. So our next lecture is from the Dr. Naresh Selokar, sir. Respected sir, you are now co-host. He will deliver the lecture on the somatic cell nucleus transfer and the cloning technologies, future tools for the sustainable indigenous cattle farming. So I request Dr. Naresh Selokar, sir, to please deliver your lecture. Dr.
Yeah, very good morning. I'm audible or no?
Yes, sir, audible.
Okay, audible. Huh? And the slides is in the presentation mode.
Yes, it is starting.
Yeah. Slides are there in presentation mode or what?
Not now, sir. It is in process. Yes, sir. It is
Now?
now showing. Yes, sir. Yes, sir. It is seen.
So it is in presentation mode, okay?
Yes, sir. Yes, sir.
Okay. First of all, I thanks to Dr. Mane and his team for giving me opportunity to share what we have been doing in my institute, National Dairy Research Institute. And just before, excellent presentation and information has been given by Dr. Giovanni. This is technology is particular context to the genetic improvement. There are so many other techniques, and now our laboratory at NDRI we are working on the fourth generation or fifth generation technology, which is already been in consideration to be translated into the field in future. So this is what I've been talking about, the futures technology. If you talked about the 10-15 years before, when about the embryo transfer technology in the country, nobody was imagined, but today it's a reality, and many people, including the state government of Maharashtra, private industry, they are extensively using this technology for the genetic improvement of our indigenous animal. So I will just give you updates about the technique which my laboratory is working from since many years, about the animal cloning technique and how this technology can be used for multiplication and conservation of the India's animal genetic resources. So as I belonging to this institution, the National Dairy Research Institution is a premium research institute. So we know that many people can aware that the NDRI has been located in the northern part of the country, and it has a footprint in the all over the country as well as in the overseas, where the majority of our human resource, either the student, faculty or researcher, they have been trained at NDRI and they utilize this technology. Who have been now working in the embryo transfer, the majority of them, they have been trained at NDRI, and some they are trained in our laboratory here. So what we have been mandate, we work with the different animals, we particularly indigenous animals. We have a cattle, buffalo, goats. In addition to that, since it is a research institute, so it has been a laboratory animal, we have a semen station and a milk processing plant. So my department is particularly, I'm working on the animal biotechnology, and my lab is particularly focusing on the reproductive biotechnology, where we worked on these animal cloning. We also work on the opioid, but not what our target is totally different than what the actually at the field level the people they use for the multiplication. Our target to do the R&D and other labs like proteomics, genomics, stem cell and everything. So Dr. Vishnu has already been informed about this, how this embryo technology, particularly in vitro embryo production. Now if we see the global scenario, in worldwide, it has been replacing the in vivo embryo production with Brazil, in USA or any country you can talk about. They have been extensively utilizing this technology. And in our country, though we have been a bit late as compared to the techniques which have been already been utilized in the other countries, but to considering the fact that our scenario is different, because we have a smallholder farmers which has kept the one or two animals, and the other technique which has been extensively applied, this technique, they have the very big farms. So there the implementation of technology is easy. But if we look at the trend from the last couple of years, now there are being some of the emerging farms which has the 1,000 animals, 500 animals, the private players, they have been coming forward to establish the animal farms in India. And in that scenario for the future, if it goes well and it is big farms, the implementation of such technology has been really extensive. So I will not discuss why the embryo transfer, because Dr. Vishnu has already been given excellent talk and updated about the government of Maharashtra activity about the embryo transfer, and what they are doing is really good. So I will just skip this one, but I will focus on the technique which we worked here at the NDRI. If you look at the how the animals are reproduced, so animals are reproduced either by artificial insemination, because most of them you are veterinarian, so I understand that you know how the animals are reproduced by artificial insemination, embryo transfer, and now with the OPU IVF, where the 50% genes has been transferred from the dam site and the sire site, that is father and mother, and the 50% gene has been transferred. In case of the cloning, there is 100% gene transfer. If you took the cells from the female, the female will born, and the 100% gene transfer. Similarly, a cell or somatic cells from the male or bull, there is a bull will be born, and there 100% gene transfer. That is the advantages of this technique, animal cloning technique, where the 100% gene transfer, and where we look at how this technology will be important for our context. So in this direction, when I was doing my PhD that time, so we produced this clone buffalo, and subsequently we have been worked to refine the protocol and so and so, and now it is very well established, and we are now with our council, Indian Council of Animal Research, as well as the Department of Animal Husbandry, how best this technique can be utilized in our country for a benefit of our dairy animals, particularly buffalo and cattle. Both the animals we can see how the best this technology can be used. So at NDRI we use this micro manipulation. I will not go into the detail about how this micro manipulation free, but just keep it in the mind in that NDRI has been working in this technique since more than 15 years, and they have been very well established. Everything data has been generated, all the aspect, not only in terms of the animal production, the efficiency, there are molecular level like the DNA changes like methylation, transcriptome, proteome, everything we have been done, and now we have been suggesting that how the best this technique can be utilized for the further. So regarding the cloning, so if you look at the cloning technique, so in our Puranas or in our literature, ancient literature I can say, Vedas and Puranas, it has been mentioning that, for example, in Rakta Bijaits, we know that there is a story about this one, how from the one drop of this blood, this one demon can be produced. And that is then hypothetically or in principle similar to the animal cloning, where the any body cell, either it is a blood cell or it is a skin cell or it is a tail cell, the any animal can be reproduced, and that is called the asexual mean of reproduction. In other methods like OPU, IVF or ET, all they are sexual reproduction, but asexual reproduction is also in common. And worldwide, if you see the almost whatever the species, either it is a laboratory animal or it is a farm animal, they have been cloned using this asexual mean of reproduction. And best of that one, you can see the couple of movies also and couple of documentaries highlighting how this asexual mean of reproduction can exist in the nature, as well as can be possible for the future application. This is just a first report of a worldwide cloning technique. So if you see, it started somatic cell, from the somatic cell, that is important, not from the embryo cell. First was reported in the Scotland in the Dolly. Everybody knows this Dolly is a famed sheep, is produced in 1996, and subsequently different countries they are producing the clone animals, and now there are commercial companies. If you talk about the Brazil, United States, South Korea, Japan, China, Italy, and in Australia, New Zealand, they have commercial companies available already to produce the clone animal according to their need. And in India, we worked at NDRI and we produced in 2009, and we are continuing this journey. But why we need this cloning technique? Similar to the IVF technology has a different purpose, and cloning technology has a different purpose. You need to understand where it can be applied. The first important, you need to have a best genotype animal, either the genotype or in terms of their production. Now, for example, the cow or a bull, a progeny tested bull or cow that can give the 6,000 kg of a milk in a lactation, and that could be the highly top tier animals. Not similar to the kind of embryo transfer or AI, it can be utilized at the farmer level. It has been meant for the specific purpose to produce the donor animals for the OPUIF or to produce the bull for the artificial insemination. So that's the purpose, the top tier elite stock can be cloned. Another is that since we have a highest diversity of livestock species and couple of breeds, I can say the breeds of the cattle, it has been very low population like 10,000, 5,000. If we are not able to conserve them, and then future these animals can be extinct from our germplasm. So to conserve these breeds, the cloning technology is the best option because it has given the 100% gene transfer. For example, Pongunur cattle, if you cryopreserve the cells of this somatic cells from this animal, and in future you can resurrect that genotype to get them to repopulated. And as per the guideline, at least 4 female and 4 male to be produced to this approach so that they can maintain the diversity for the future. And third approach is application, I can say. It is the production of the gene modified animals. That is the future. If we are producing such an animals which has been highly efficient in terms of the milk production, highly efficient in terms of the meat production, or they are being resilient in terms of the climate, or they are resilient in terms of the disease outbreak. For example, by any means we cannot produce the FMD resistance animal by any technique, except we have been changed at the gene level to make such an animal is that they can produce their resistance to the particular disease. Or similarly, by any means we cannot produce the animals which is given to 10,000 or 12,000 kilogram of milk yield in per lactation. But if you know this gene to be modified, because all the phenotype, we can say, it is for phenotype means in the production trait, it has been all governed by DNA and the regulatory mechanisms like mRNAs or the transcript, and they have been governed. If you change that mechanism of that pathways, so you can expect that particular phenotype. And this is just as I be working in the buffalo cloning since many years. These are a couple of achievements we reported scientifically in this literature. So multiple copies can also be possible. So like for example, this is the top tier first rank progeny tested bull, and we have 3 clone copies, and subsequently clone bull has been used in the field for the artificial insemination to see how this productivity can be enhanced. Also we tested for the IVF, we did it for the artificial insemination, semen parameter, CASA indices, so other thing has been done. This is one case study which I did during my studies that long back. So one possibility is that, for example, if we have a cryopreserved semen in the biobank, but the bull is not available, bull is already died. So for after 10 years or 20 years, if from the somatic cell can be cultured from the frozen state, and if that cells can be gated, and then we can resurrect that bull for the future. For example, like 50 years before, the bull has been died, but their semen is available still with the biobank, and from that frozen semen we can reclone that animal using the isolated somatic cell. That was this one, and this bull is now with at NDRI is more than I think now is 12 years around of age, and this bull has been produced the semen. We check the semen, we produce the next generation offspring, and they are all of the normal. This is we also did it for this Assamese buffalo clone. So a distant animal, for just an example here, the animal which is located in the northeastern part of the country like Assam, it can be shifted, the tissues only we require the small pinch of the biopsy to be shifted into any laboratory in India, and then we produce the embryos and then transfer into the other breed like Murrah buffalo we tested. This was a male we produce for obviously for the semen production. We check all this one, hematology, serum biochemistry, chromosomal analysis. We produce semen, CASA indices, and then fertility IVF. We did it and test it is normal. So that's this one. We also check the fertility with the IVF and AI, and all these parameter, transcript, mRNA, mRNA, IVF, AI, everything. And recently, CIRB, my previous institution where I work, they have been transferred these 3,000 insemination using clone bull semen, and they got the conception rate of 40 to 50%, and this offspring is also born, and then now they are recording these milk production. If you see, look at this, how the technology has been done. If you validated the technology, and to produce in case of the larger animal, it takes the long generation interval. Like for example, this in case of buffalo, so to produce the 10-month of gestation period at least, and the maturity may be 2.5 years or sometimes 3 years, and then 1 year again to pregnancy to record. So 5 or 7 years has been required to prove that this using this bull semen how the milk production has been improved. But we achieved that, and now this year we have been in touch with the government of India to formulate the guidelines and the regulation how this technology can be used. Since with the many people have been now in country, they have been utilizing the OPU IVF technology. So how this technique can be integrated with this approach to allow the faster genetic improvement. If anybody is interested to research or they would have more idea about this, how the cloning has been worked and what was the application, so these are a couple of our scientific publications, they can go through this publication. And now coming into this cattle cloning, we thought to have buffalo, we did so many work. In cattle, we have a problem with the availability of the oocyte because the cytoplasm we use from this oocyte, when the OPUF has been initiated in our laboratory again, then we isolated the oocyte from the crossbred cow, Saiwal or any breed oocyte can be isolated. And suppose for example here we wanted to clone the Gir cattle, so Gir somatic cell need to be established and oocyte from the any breed to be cultured. And then this is a technology we established at NDRI. We produce the clone embryos and then transfer at Dr. Vishnu has been made crossbred cattle or any cattle which has been low producer, which you consider as the surrogate mother can be used. And after the embryo transfer, you can expect the clone cows which is genetically 100% identical to that of the cow from where the somatic cell has been taken. This was a new initiative. So in 2023 we started. So we initially worked with this approach through the OPU, we isolate oocyte, we proceed with this cloning method. This is the metaphase plate of the enucleated oocyte. And then this is simultaneously, for example, to have the somatic cell established from any animal to be cloned, and then you reconstruct the embryos, then fuse, and these are the in vitro produce the embryos of a clone embryos, and we produce from the Gir, Red Sindhi and Saiwal. Initial experiment we collaborated with the Kalsi firm, Dr. Aswan, and now we have been doing at NDRI for these, for example, Gir and Saiwal and Thar Parkar. So this we did it. So with this initial attempt we produced the clone cow. I think you people are aware of it. India's first cloned Gir cattle that belongs to the Gir. So there we isolated the oocyte from the Saiwal and Gir somatic cell, and then produced the embryos, transferring the crossbred cattle, and then produced in 2023. And after this one, when this Ganga has been born, so we thought to utilize this as early as in the 19th month of our age. We superovulated again with this clone cattle for the OPU. So this is the superovulatory from this animal. We collected again and we produced the IVF, and then IVF zygote has been transferred into the Saiwal cattle, and this daughter of the clone cattle we named as Shravani, and this was born in the last year. So why we did this is all our experiment is not for the generally just established technology experiment. We have to prove something scientifically or to conduct some scientific research. So how this technique or approaches to be utilized for the field application. This is our idea. For example, conventional breeding, either you can go with the OPU or normal technique like AI. So for example, high genetic merit calf is there. In case of cattle, this is an example of in case of cattle. So it takes a 20 to 24 months to attain the puberty, and after puberty you can go for the artificial insemination or embryo transfer to make them pregnant, and then it takes the 10 to 12 months of age again. So this is the first generation, it takes the 30 to 35 months, and after again this the same animal with the second generation go with again the same procedure of 20 to 24 months of gestation period, puberty age, and then you inseminate or make them pregnant with the embryo transfer. It take again this one. So second generation calf will born at the 60 to 72 months. This is a minimum time frame to require for the conventional breeding. So how we have been the speed breeding approach, what we have been suggesting or can be possible to implement is that if we have the high genetic meritic bull, so instead of going for the normal puberty or to attain to make them pregnant, so at a calf stage now, because of genomic selection everything is there, So at a very early stage, you can produce by the cloning, like to establish the cell and the same gestation period using the surrogate sire inhibitor. The first generation calf can be born at the 10 to 12 month when you have the high genetic merit calf. And then at a very early age, like 18 months, what we have been done in case of the Ganga, at a very early 18 month of, you do it with the OPU cycle and then collect the oocyte and then produce the embryos in vitro and again to transfer into the next surrogate sire. So the next breeding cycle will go with the OPU 10 to 12 months. So second generation calf will born in the 30 to 32 months. That will be reduced the half of the time to achieve the generation. That is what we have been suggesting, so that it is an integration of both a cloning technique as well as the OPOIF technique for the faster multiplication of the elite germplasm. This is what we have been suggesting to that how this technique can be utilized. For example, we have a top quality tire genetic merit bull. So either you can use with the classical breeding or OPOIF technology, you generate the cows, and that's a common practice worldwide. It has been utilized. But what we have been suggesting that if you have high genetic merit bull, you can clone that bull with the technique what we have and produce a couple of copies, like 2-3 copies, and then these clone bulls can be utilized again with the classical breeding as well as OPOIF technologies to generate the next generation calves. So what happened is the next generation calves number of with the superior genetic trait or the phenotype, that will be the very, very high as compared to the conventional breeding approach, either with the OPOIF or classical breeding. That's one. And similarly, just an example, we need to think in the long run, like what will happen after 50 years or 60 years. So all the technology, if we talked about the artificial insemination, if we talked about the embryo transfer, all the techniques, they have caused the inbreeding, but extent of inbreeding is different in different technique. If everything goes with the cloning technique, the extent of inbreeding is very, very high. To avoid that, what we have been suggesting, for example, the animal that belonging to the Haryana state, that animal should not be, the clone copy should not be utilized in the same state. It will goes to the different state. For example, it can goes to the Andhra Pradesh, it can goes to the Karnataka, Bihar, Odisha, or any other, even Maharashtra. It's also possible if the breed is being prevalent in that region. So that's our approach. We have been suggesting also, since we have high genetic top tier animals, so we can tap the international market by exporting their genotype either to the Asian countries or Latin American countries like Brazil or Venezuela, Colombia, where the buffalo is dominant. This is an example for the buffalo. In cattle also same can be done. So, and what we have been also suggested that the bull semen should not be used more than the 2 years to avoid the inbreeding, and that in principle is same for the OPOIF also. For example, the douters cannot be inseminated or produce the embryos of the daughter with the her sire semen or father semen, that to avoid the inbreeding. So that's we are also suggesting the same thing. Let's see how this the regulation, everything will goes with this to maintain the diversity and regarding the cloning aspect. So another this approach we think, because in the cattle cloning we struggle a lot. So to get the OPU oocyte, because we need the large number of oocyte to perform the experiment, and so we thought to utilize the interspecies cloning. So interspecies cloning, we are working on this. Very recently we started to think of how, for example, the Gir, Sahiwal and Badri, so three breeds we are targeting. So somatic cell from this breed, but oocyte from the buffalo where the DNA has been renewed. So the cytoplasm of the buffalo to be utilized to generate the embryo. And this is in vitro data. We have the Gir embryo development is 7 to 10%. They reach to the blastocyst stage. We have not yet transferred these embryos to achieve the pregnancy, but probably when we transfer this pregnancy, these embryos into the recipient animal, like crossbred cattle, we have to check they are really implanted or they are able to produce the offspring or not. If we would able to succeed to produce an offspring, 1 or 2 offspring, then we can scale it up with a different approach. That's the future target. But in case of Badri, none of the embryos they have been arrested. So what that could be because the genome of each breed is different. So maybe Badri genome is different, Sahiwal genome is different, and Gir genome is different. And to reprogram that genome to this embryonic stage, it required the different factors which may not be supported by the buffalo oocyte for the Badri, and that's why they have been arrested at the 8 cell stage. So, but the more studies are required so that we can be done. This is just one master thesis has been done recently to see how the embryonic development is there. And the embryo quality, if you look at the embryo quality also, is not as good what we have been expected with the same species oocyte. But the embryos they are developed, that is a good indication for us that this way also can possible to produce the animals in case there is no other option is available. So for example, OPU is difficult particular breed, or there is a lot of cost investment in case of the oocyte get it from the OPU, because you need to hormone, labor intensive medias and everything, because the buffalo oocytes are available at the cheaper rate from the slaughterhouse, so we can produce this kind of the embryos with the buffalo oocytes. And now the department has also been requested that to produce this clone for the Tharparkar bull, which is available at the, so I think, Suratgarh farm. So we collected the somatic cell. We produced the embryos also in vitro. Some attempts has been made, but we could not transfer these embryos for the recipient animals. So, but our target in this year or next year to clone this animal to see, because now we have been scaled up about the OPU also to develop our medias and everything, and how the problems have been facing by embryo technologies in the field. For example, the transport of the oocyte from one place to another place, how the oocyte to be efficiently transferred so their developmental competence should not be compromised. That is our future questions we have been asking, and in that direction we have to formulate some of the components or medias or direct embryo transfer techniques. So this we have to be keep it in mind. So we have to scale it up, and in the meantime we will utilize this TP bull, particularly male. This male, which they consider as the top target. This bull is now dead. It's not available. This animal is dead. But we have biobank these cells, and in future we wanted to resurrect back with this bull to the cloning technique. The another just I would like to highlight about the gene editing. So changing of the gene in livestock. So we know that the phenotype, if we say the milk and meat, which is governed by the DNA, and this industry demanded, for example, milk industry, meat industry, they need the high quality of milk or high amount of milk to keep the minimum animal and produce more milk. Everybody's want that is industry, and if you change with this gene to achieve that phenotype and in the minimum number of animal, higher productivity, because we are milk high rank first milk producer, but at the same time our productivity is far lesser than that of the global average. So we need to achieve that high productivity, and that's why in all the aspect, either in the genomic selection or nutritional management or embryo transfer, all they are working together to achieve the higher productivity for the future. And similarly, gene editing and cloning can also be working in this direction. So this is the CRISPR technique. So how the CRISPR has been used. The CRISPR is particularly, it goes into the eukaryotic cell. They make the cleaved double-stranded break, and then when there is a double-stranded break, a DNA repair pathways has been activated. And so it is the NHEG pathway or homology directed repair, and through this approach you can modify the gene. You can add any gene, you can add any nucleotide, single nucleotide, 10 nucleotide or complete gene. You can delete anything or you can modify it. So you can change with the SNPs and everything. And this technology is now been extensively utilized in different species. In livestock, in crops, you have been heard about this. ICR has been produced the gene edited rice for the commercial application, and we are working in the livestock science. So we also produce the gene edited livestock, and we wanted to utilize this technique for the future improvement of our indigenous livestock germplasm. And worldwide, this technology extensively utilizing, and recently in 2025. This United US FDA has been approved the PRRS resistance pig. They have been the porcine reproductive respiratory syndrome resistance pig. They have been produced through the gene editing for the commercial application. So we in future also we suppose for anything where livestock has been imported from the world, we may get the gene edited the genotype or this biomaterial, like example sperms or oocytes or embryos which have been imported from the world. So in case of since we have been initiated this work in buffalo, so just I would like to highlight about the buffalo. So how this important in buffalo, the meat production, because buffalo is meat animal. So increase in meat production, the milk production from low producer to high producer, disease resistant, and climate resilience. So my lab has been working in all these aspects. So, but I will highlight a couple of only case studies because other work is being under process. So what we thought to normally the buffalo to produce the broiler buffalo, like a broiler chicken, the calf has been born to achieve the slaughter weight of 400 to 500 kilogram. It takes 20 to 25 months. And we thought, can it possible to achieve in 10 to 12 months a period of time to have that slaughter weight. So why? Because we know that the buffalo meat export value is very, very high, and that has been important for our industry. So we mutated this gene called the myostatin gene in buffalo genome to achieve the faster growth rate as well as meat yield. And this was our success stories. We proof of principle study. We produced the myostatin gene edited buffalo. And if you look at this, the birth weight of this gene-edited buffalo is similar to that our clones, what we have been produced. Our wild types mean AI born animals. And if you average daily gain per day, how much the average daily gain? If you see here, more than the 1 kg, which is far higher than that of the AI born cows and the clone cows. And if you look at the phenotype also, this is the completely higher masculine, and that need to be future to be tested in the larger extent also to produce the next generation offspring. There are so many data need to be generated to prove that the technology is going well and is fit for the translation in future in the form of the semen, so that we have like a dairy industry. In case of buffalo, the broiler industry should also be established. That's the future target. And this is some scientific data like meat analysis, the histology, and then analysis. This is the protein level, how this myostatin has been ablated to confirm this scientifically that this animal is being mutated or lack of the myostatin in their muscle mass. This is just I will sum up. I will not disclose many things which we have been currently working because of I have given a time of half an hour. Also, I thought to just highlight about the technique about these animal cloning as well as the genome editing. Some of these one case studies I shown the myostatin knockout, but we already produced the other trait. For example, altering the milk trait, a climate resilient animal or disease resistant. We are working on that, and we have animal here at NDRI also. And these in future we need to generate the data, and then when we generate the data, this will be more suitable. So more than 30 clone buffaloes we produce, and 1,200 these offspring of the clones. And genome editing we have been initiated from last 4-5 years, and more studies need to be done, so that to generate the health profile, growth profile, how this technology is to be implemented in the field level. And obviously we have a highest opportunity, but at the same time it's very challenging to work with the different species, like our conditions, our animal genotype, what were the resources we have available, that all need to be done. I would like to thank these fundings which has been supported all these works. This majorly funding from the Indian Council of Agricultural Research and from NDRI. Also we have a grant from the Gates Foundation, also from Department of Biotechnology, and obviously the students and project staff are dedicated with us. So we have a farm staff as well as the laboratory staff who work with all these techniques. So I thanks to them. Thank you very much. I would like to take any specific questions if you have.
Thank you very much, sir, for your nice presentation on the aspect of somatic cell nucleus transfer and cloning technologies. I would like to call the audience and participants to ask any questions about this topic to Dr. Naresh Shilokar, sir. Any question from anyone?
It's okay. If there is no questions.
Okay, as it seems that there is no questions, then Sir, Dr. Nitin, Dr.
So,
Naresh Shilok.
one question, sir. So, has any animal, the clone animal has come to the milk?
आणि विटॅमिन मल्टीव्हिटॅमिन आहे का बी कॉम्प्लेक्स वगैरे
Hello.
आहे थोडी एक छोटे उदाहरण
Hello.
Yeah, any specific questions or?
So, has any cloned animal started producing milk?
Yeah, not one. There are many animals that produce milk.
And
I have not
they
shown the
are
data about this production, milk composition, and everything.
and they are in par with the mothers.
Huh?
Their performance is in par with mother.
Yeah. Their performance is normal and as good as their donor animal, not mother.
Donor
Here
animal.
we can say as a donor animal. So that all the data we generated like compositional analysis, detail analysis, as well as the milk production trade and everything. So we all this information we submitting to the government of India, particularly Department of Animal Husbandry and ICAR, to consider that data and then make this how the best to utilize the insurance technology in the field.
So is it available online? Can I see?
Data is not available because this data is belonging to ICR and NDRI. So only those are publications we publish that is available, but other data like breeding and everything we are not yet published, so it is not available. It is with us only.
Thank you.
डॉक्टर सर वन क्वेश्चन फ्रॉम माय साइड
Yes.
Hello. One question from my side. I want to ask about what is the first such product for one embryo production average.
What is first?
Clone animal production cost.
Clone animal production. So if you see what is available with us.
Production cost.
Yeah. Production I will tell you. So first donor performance we have reached around the 31st 3,100 kgs per lactation, something around this.
No. I want to ask about what is the production cost of one embryo?
Embryo cost or animal. Okay, got it.
Yes.
So
What
the
is cost
embryo
of
production was now, for
embryo?
example, yes, now we have through the ITMU embryo production cost. If anybody interested, particularly for buffalo to clone, or they can contact to us, and we charge of around the 20,000 rupees embryo cost, one embryo, 20,000 rupees around. Okay, and if they want a clone animal to be born with us and to produce everything, considering all the factor, recipient cost, everything, we charge around case to case basis 25 lakh to 30 lakh rupees per animal, and that is
25 lakh.
yes, 25 lakh around.
Suppose I want to purchase clone embryo.
Yeah, you can purchase embryo, no problem. So it is a 20,000 rupees embryo. 20,000 or 15,000, it depends upon the how this negotiation has been done between our consultancy cell.
Can available this now? Can available this now? Available, sir?
Available?
Embryo available है क्या? मिलेगा क्या?
Yes, you have to write to our institute, the director and ITMU, and then we will negotiate which type of embryo, because you see, each animal have the different embryos. For example, the buffalo is a different, cow is a different, that animal cost is different. Is all the case to case basis. I am saying a generalized 15 to 20,000 rupees. Now we have been negotiating with the Banas Dairy. You heard about the Banas Kata Association from Gujarat. So we are negotiating with them how the best can be done to MOU. We are working with them to how the best can be implemented. If you are also interested, you can reach with us, and then we can discuss what kind of the animals you want, which genotype you want, what is your demand. Like for example, not only one embryo you will ask and we will do it, because each experiment has to go with the different flow. We need to produce trials to conduct one trial, 10 embryos, 5 embryos. So minimum also requirement is there, like at least 10 embryo order to be there, so we can conduct, because we need to run the complete set of experiment from the cell isolation, embryo production, and then if you are not fresh embryos, then we need to frozen also that embryos, that all need to be considered. But it is possible, there is no problem with us, that we can discuss and collaborate, or we can go through the consultancy to provide you service.
Sir, myself, Dr. Jadhav, I am so good presentation. So, how much productivity presently in Murra in Karnal, so that we can get a cloned embryo?
Sir, currently
Highest
our
productivity.
highest
Saival and
productivity of around 4,000, around 4,000.
4,000 in Murra.
Murra, yeah.
And in Saival?
Saival, I think, is same, I think 4,000 or 4,500, or
Okay.
around 5,000 maybe, probably. Saival is a
Okay.
little higher, right?
So the clone,
Exactly.
okay, so the cloned embryo will be available with this much production potential.
Yeah, that's what I'm telling. So it's all depend upon if anybody requested that they want to clone embryos of particular animal, then what is availability with us, the animal is available or not, how many embryos you requested. But anything can be possible. Embryo, we can provide the embryos to anyone on a charge basis.
Okay. Thank you.
So one
Thank
more
you.
thing, sir. Sir, is it possible for a farmers to clone their own cows? Can you provide the service?
That was, I was tell, if any farmer is interested to clone their animal, if they have to approach to us, we will make an agreement with them, how much they would like to pay. Either it's a buffalo cost is different, cow cost is different, how many animals want, that is also different. They want one animal, 1 copy, 2 copy, 3 copy, is all depend. So but it is possible to get these services from India. They have to just approach to us.
Thank you, sir. Thank you.
Is anyone has any query? Okay, it seems that there is no query from the participants. Dr. Nitin, Dr. Naresh Shelokar sir, Senior Scientist, Animal Biotechnology Division, National Dairy Research Institute, Karnal. I am very thankful on behalf of Ajit Dada Pawar, Indigenous Cattle Research Cum Training Center, Agriculture College, Pune, for your nice presentation on role of somatic cell nuclear transfer and cloning technology, future tools, and sustainable indigenous cattle farming on the occasion of national conference. Sir, once again, I am very thankful for your presentation. Thank you, sir.
Thank you very much, and best wishes to everyone. Thanks.
Thank you. So we are moving towards the next presentation, and the topic of this presentation is role of Gaushala in conservation of indigenous cattle breeds and promotion of sustainable agriculture. And the speaker is Dr. Nitin Markande sir. Markande sir is a ex-associate dean, veterinary college, Parvani, and he has a vast experience of teaching, research, and extension work in the field of veterinary science of more than 30 or 35 years. I welcome Dr. Nitin Markande sir on behalf of Ajit Dada Pawar Indigenous Cattle Research Cum Training Center in this national seminar. And I request sir to start his presentation.
Thank you, Dr. Bhalerao sir. I'm really very happy that I have been given this opportunity to be with you for this national conference on sustainability of indigenous cows. And really, I'm happy that since morning we have attended 3 very lucid type of lectures, starting from the microbial resistance and the milk and the role of the cow in providing good quality of the milk. Second, we have gone for embryo transfer, and slowly one step ahead, all advanced technologies we have learned from Dr. Selokar sir. And it was a very nice to attend this type of seminars, these type of lectures. Now my topic, the first slide is not visible, sir. So let us go to the first slide. See, if we go to the these type of technologies, these type of achievements, then I personally feel that we have to discuss and we have to be with the ground realities in our country as far as the conservation of the indigenous animals is considered. So although we have technologies and the science is advancing well, but as far as the field experience is considered, it is not so much encouraging one for we all. So may I have the first slide? This is something in between, I think so. Sujit ji, can we go for the first slide? Hello.
Yes, sir. I will move
Please, please go to the first slide. I think this is second, third, like that. Yeah. Starting with the first. Yeah. So the friends, we are going to discuss the topic of Goshalas and the conservation of indigenous cattle in Goshalas. For both, for genetic improvement and for the conservation of the Indian cattle, and also for sustainable agriculture. Both the things are very, very important, and they are close to the heart of every Indian. The friends, I will be focusing on present scenario of Gaushalas, and for future strategies we should plan for overall development of the Gaushalas. So these are all the ground realities, and you may not accept many of the things because the things are really not so encouraging as per the Indian expectations are considered. So coming to the next one. Now this Goshalas. Next, please. Next slide, please. Now, as far as the Goshala is considered, it is a rearing center for the Indian cattle, and right, if this is second one, then we are rearing Bos indicus type of animals in our country, and basically the cows are reared for milk purposes, that is for family milk. Second, for manure to supply to the agriculture, and whatever the males we are producing, that is for the agriculture energy or agriculture operations. We have highest cattle population and highest milk production with our strength and the population. This particular term Goshala is a very, very broad term. Every time we use the same term, even if it is with the private firm, or even if it is with any trust or any registered type of organization. So two types of different type of approaches are there for running a Goshala, for maintaining a Goshala and managing the cows. Anything which is more than 10, any unit which is having more than 10 animals, that is called as the Goshala. If my private farm, I will say that my Goshala is there. So this is a broad term, and we have to take it in a very positive type of the sense like this. The very strong desire is there amongst the Indians that we should conserve our Indian cattle, the potential of our Indian cattle, and Goshala as extreme are in existence since last 300 years. Friends, it is very important to note that whenever there is a mass rearing of cows by the say organizations, units, trusts, that type of activity is going on since last 300 years. And many Goshalas, if you visit, they will say that we have the legacy of 200 years, 150 years, 250 years, like that. Next one. So this is the type of structure when we are having Goshala. The private Goshalas, those are individual properties, remember. And a persons and even the villagers, farmers, they say that, yes, I am having 30, 40 cows and I am rearing those cows for my agricultural purposes. Now, these cows, they are providing the basic support for agriculture. And in this type of units, a private person is providing some or other type of technical inputs, that what is going on in animal husbandry sector, what is the type of advanced managemental practices for the cows. So those type of practices are adopted in private type of Goshalas. The expenditure and profit is regularly maintained. It is evaluated, analyzed, and accordingly the animals are reared by the private goshalas. It is also important that these type of considerations, they maintain a limited type of number. No private goshala is more than 30-40 animals. Maximum number is 10 to 20, like that. So it is the first. In case of trust goshalas, first and the foremost thing is that they have registrations either with the charity commissioner. These are the trusts, these are the temple goshalas, or these are the unions, these are the organizations which are running these type of goshalas. These goshalas, they maintain the cows without emphasis on how many numbers they are rearing. That is most important one. Another important thing is that whether the profit is there or not by rearing of these cows, how much stock is there, how much stock is increasing, what type of productivity potential these animals have, and what type of improvement they should consider from the inmates or the cows. So this is not at all there in case of the trust goshala. We have to focus these type of goshalas in particular in today's deliberation. Now these goshalas, they carry hundreds of non-productive type of animal, and they are these goshalas are proud that yes, we are maintaining the animals which are not productive one, but we can very well maintain them. They are very proud about this type of maintenance of the cows. Next one. So this is the basic difference in private. Now what is the need of the hour? It is the need of the hour is to think the fate of the trust or the public type of goshala. Yes, we are very happy that a trust is running goshala with 500 cows. But what is the objective to run this particular goshala? Who we are going ahead as far as the improvement is considered? That is the important question. Another important thing is that constantly the number is increasing with the force from government type of laws, with the force from the farmers adjoining that particular goshala. Everyone is interested that if animal is not productive, let us put that particular animal into a goshala. And the acceptability of goshala is wonderful, that let there be 100 cows in a month, the goshala will accept those type of the cows. So, and they are really, we should appreciate their acceptability. The next important thing is that having the tremendous scope for improvement of management and genetic improvement of the cows. Every goshala is having a tremendous scope for managemental improvement approaches, genetic improvement approaches for the cows they are maintaining. This particular strategy is questionable. This is not followed by the goshalas. So they should inculcate in them the sense of genetic improvement in them. Previous slide, please. Previous slide, please. Previous slide, please. I will come to you and I will call the next slide. Yes. Now, what are the necessities? It is most important that what are the necessities? In the interest of potential animals, we should improve cow-based agriculture. We should protect environment. We should protect the animal and human welfare through these goshalas. This is the necessity. So our agriculture must be superior with the help of goshalas. Our the environment should be very clean and very comfortable for all human beings. So this is the expectation from goshala, and this should be the objective that we have to maintain goshala for potential improvement in agriculture. The next one. Now the next one. Yes. Goshalas can be improved and those can be made totally sustainable on dry dairy model. I accept. Initially, I accept because no goshala in Maharashtra or in our country is interested in the milk of the cows. No goshala owner or the trustee will discuss anything about the cow milk. They discuss everything about the dung. They will discuss everything about the urine, all of the productive potentials of the cows, but not the milk. Why it is so, that I don't know, but it is the ground reality that goshalas are running with dry dairy models. Second important thing is that the utilization of the cow products like dung and urine is taught by the goshalas, but in actual practice, the goshalas, they are not utilizing the even cow and the dung in the total manner. This is a ground reality that goshalas they have done, goshala they have cow urine, but the utilization or production type of the things, those are very less, and that is not being utilized in a proper manner. Another important thing is that the potential of Indian cows, whatever is the potential of the cows, and what type of benefits we are getting from the Indian type of the cows, those are not justified by the goshalas. Many goshalas, they know that how Indian cow is beneficial for the human sustenance or the human life, but goshalas, they are not attempting such a type of the things as on by rearing the cows. Another important thing is that skillful orientation of Indian cattle rearing is important one. Skillfully, if we rear the animals, say 300, 500 animals of the goshala, that will suffice the purpose, and then only we will have the ideal type of goshala management. The next one. Yes, next. Yeah. Now, breed evolution. How this country has evaluated breeds. We know that at the time of independence, there were 30 different breeds, Indian breeds, Boss, the Indicus. Now, particular locality, particular region was carrying the animals or the cattle of the same phenotype. Every time breeding was related with the limited number of animals of same phenotype in that particular area. Say, for example, Vidarbha area. So in Vidarbha, there was only demand, the interest, and there was potential to rear Gaulau type of cows. Western Maharashtra was more focusing on killer type of animal, and the people from this region, they were interested to develop their own animals, which are local one. Slowly, this particular number at the time of our independence was 30. There were 30 elite Indian breeds when there was independence. Slowly, what happened? The interaction between the regions was improved, and the people from other region, they were interested to carry the animals, and particularly the breeds from other regions for maintenance, rearing, with their increased interest. The same thing happened for the Gir. The Gir is very popular, and Gir is called for by all the states in our country. Similar manner, Panganur. People, they are really searching for Panganur like anything, as if there are no other breeds for the cows. Only Panganur is the breed which is potential one. So similar type of approaches they have made by the people. 4 to 5 Panganur cows, if brought from say from Andhra Pradesh or from Tirupati, and if the males are not available, then the people, they go for breeding with available type of males, any type of indiscriminate inseminations they are going on. So these are all the problems which are related with the Indian cattle, that if we carry or if we bring the breeds of from different regions, bulls are also expected, semen is also expected, straws are expected, then only we can maintain and rear purity of these breeds. This has not happened. As far as the 30 Indian breeds were considered, their potential was very less. Only 4 breeds were meant for milk purposes. Other breeds were draught purpose and the dual purpose breeds. And therefore, there was a dire necessity to cross the available Indian stock with the foreign type of the breeds like HF and Jersey. And here we have lost more number of purebred type of animals, maybe those 30 purebred animals of that time. Now, friends, it is important to note that crossbreeding has led to many type of challenges in our country. Improved nondescript population is the first and the foremost loss of our country through nondescript, through this crossbreeding type of program. Crossbreeding program was not at all meant for any purebred, Indian purebred. It was only meant for nondescript type of animals. But when the strategy was followed, when the policy was followed, the n number of mistakes, n number of flaws, they have generated nondescript population. And the friends, this crossbreeding type of program, which was followed from 1970s to 2020, this has led to a situation that as on today, Maharashtra is having 95% nondescript cattle and maximum number is in Goshalas. So there is a necessity that we should go for reducing this nondescript population, and we should have the more number of the descript type of the cows. And Goshalas are expected to think in this manner. Next one. The next slide, please. Right. Now, many times we are very proud about Indian breeds, and many times we pronounce, or we are very much interested to declare the potentials of the Indian type of breeds. Now, friends, it is not limited to 3 and 4 or half a dozen type of characters in case of Indian cattle, but we will have to emphasize all 15, whatever I have drawn out or whatever I've checked out, but we will have to improve this particular list of cattle. And this particular list indicates the characteristics of our Indian cattle. Now, starting with the first, strong immunity to fight against diseases. Very, very important that Indian breeds, all Indian breeds, they have immunity to fight against diseases. Repellence of maximum external parasites. Friends, parasitic resistance is so important that these animals, particularly Indian breeds, they never suffer with any type of protozoal type of the disease, and therefore their repellence to external type of parasites is more. Adaptability to adverse climatic conditions. We are observing these things that we are interested in Ganga Tiri in Maharashtra, Devani in Gujarat, or the Devani in Madhya Pradesh, maybe Halikar from Karnataka to Maharashtra, and likewise many other breeds. The Kankaraj we are interested in Maharashtra. This itself indicates that these animals, they have potential to sustain in different climatic conditions, and even if the natural conditions are adverse, these animals, they can sustain well. The next one is the susceptibility to sustainability in global warming. We know all this very well, and therefore I will not emphasize this particular point. Every year we are increasing by 1 or 2 degrees, and still our Indian cattle, they are performing well. Khilar has moved to 15 liters per day lactation. That indicates that even under the warming conditions, definitely Khilar is performing the best. Next one is the nutritious milk production. There cannot be any type of compromise to say that the Indian cattle, Indian breeds, they produce nutritious type of milk. One can say this particular thing, emphasizing the utility, the potential of the Indian cows. The next one is the regular reproductive capabilities. All other animals, they are failing. All other breeds, they are failing in regularity. They are failing in longevity as per the reproductive capabilities are considered. But 10 lactations, 12 lactations, those are more than sufficient for other type of cattle breeds. But we are very proud that Indian cattle, they have proved their longevity as per the reproductive capacities are considered up to 18th lactation, 20th lactation, and this is just possible only with Indian type of cattle. The next one is the a strong power for agriculture operations. Every time, if we want the agriculture operation through the bull energy, the only Indian type of breeds, they can provide such a type of the bulls. Medicinal properties to the urine. 5 patents have already been filed, and those are in existence. We have those have been granted to India. We know that the Go Vignan Kendra developer has these type of patents, and therefore there is no second opinion about the medicinal properties of the urine. In case of cancer patients, many patients, they claim that yes, it is improving immunopotential, and therefore we are now strong enough to fight against the cancer with the support of the cow urine. The soil fertility potential, this was aptly explained by our director of research other day, and he has explained that how the cow manure and the cow dung, those are useful for improving the carbon content of the soil. The next one is the promotional support for organic farming. When we want to go for organic farming, and that is the need of the hour, this is only possible through rearing of the cows. Cow-based farming system will support natural farming, organic farming, zero budget farming, and residue-free farming. So all these type of things are possible only with the cow-based agriculture. Environment-friendly items through cow products. 2,000 products are now available in the market from cow urine and cow dung. These products are domestic type of products which are required by the families. Rich families, they are regularly using the cow products from the cow dung and cow urine. This is for the health. This is for the welfare of the human beings. And therefore, this particular list is increasing. And therefore, these environmental friendly products are only possible from Indian cow. That is also important. Utility for basic therapies in Ayurveda. In case of Ayurvedic treatments, Panchagavya therapies, and all Ayurvedic doctors, they will emphasize only milk from Indian cattle, only ghee from Indian cattle, only curd from Indian cattle. See, there is no alternative for this. When we say Panchagavya, it is from Indian cow only. So this is most important, that all Ayurvedic type of therapies, although the science and the new type of scientific approaches, they do not accept the Ayurvedic type of the thing, but it is proved beyond doubt, and it is experienced by many people that yes, only Indian type of cows, they have this type of potential. Potential to generate the gobar gas, electricity, fuel. So all type of energies, it is possible. And nowadays the see, this particular energy is being utilized for the vehicles, and we are very proud that Indians, they are proving skillfully that the gas which is produced by the cow, from the cow dung, this is most useful energy source, alternate energy source, and we are becoming Atmanirbhar with this type of energy. And the last one is the unique sense of consensus. A Indian cow had such a type of sense that the particular cow will never have attacking type of attitude with the human. We see many type of cattle shows, many type of Nandi bells. They are performing their shows on the streets, and the conscience, the sense of humor with this type of animals is a very important one, and it is a unique one. So these are all the qualities one should add to this particular list, and we should propagate this list. Next one. Now, breeding and the breed development, as per the Indian cattle is considered, the breeds, those have been developed by as per the people's choice. This particular part is more important, and it is possible to convert available nondescript population into pure-bred population very simply, very simply. That let there be 95% nondescript population as on today, but it is possible for we all to convert this population into purebreds. The first and the foremost strategy is that recording is necessary. Fixing the targets is another important one, and this is possible if Gaushalas take lead for this type of the things. Next one. The next one. Gaushala concept should not be there as a shelter house or a hostel for nondescript cows, infertile cows, debilitated cows, diseased cows, and all ailing type of animals or the low yielders. This should not be the approach. The Gaushalas established before 100 years have their own grazing lands. Friends, this is most important type of the thing, because these Gaushalas are still in continuance only because of fodder production. Fodder sufficiency is the positive point with these type of goshalas, which are old one. The new goshalas should always think that for every 10 inmates, at least 1 acre of land is required. If land is not there, if the water source is not there, if there are no proper inputs for financial supplementation, definitely that particular goshala will collapse. In India, there are 1 lakh plus, so more than 1 lakh goshalas are in existence in goshalas, and 1,000 plus goshalas are available in the Maharashtra. See the total number, and every goshala, if we consider the average, at least 300 to 500 cows are there. So this much animal potential is available in India for energy generation, for sustainable agriculture, for also for the environmental the friendly type of approach, and for the nutritious milk. These goshalas, total 1 lakh goshalas, should consider to develop themselves. They should improve their managemental practices and the genetic type of improvements of the available stock. Newly established goshalas, they have that way not having so much huge number, but they definitely they have scarcity for land, fodder, water, manpower, and financial opportunities, the capabilities. So this is most important, and therefore the technically and scientifically sound and ideal type of goshala conversion transformation is the need of our at present. Next one. Right. Constraints with the goshalas, the constant increment that these things we have already discussed, that the manpower is deficient and the regular influx is there, but it is leading to all type of problems in type of goshalas. So let us go to the next slide. Yes. Next one, please. The conservation of cattle bits. It is possible. Sincere approach to maintain the cows and their followers is necessary in goshalas. Standard rearing practices should not be compromised in goshalas. The concept of cattle conservation is not only includes the life maintenance of the cows, but it emphasizes improvement of breed and our cows. And therefore, goshala should be nurtured and oriented towards breeding centers, breed improvement units, breed advisory institutes, and breed museums. The friends, a single goshala should be an ideal model for 1 lakh farmers around that particular goshala. So farmers, they should have some type of advisory from goshala, that how to go for animal breeding, how to maintain the breed, how to improve the breed. So these concepts should go from goshala to people and not from people to goshala. So that is the more important type of aspect, and that is the need of the hour. Change the orientation of goshala as an elite breeding center for conservation of top, I will not say top breeds. If we say the only top breeds, then we will think about the Rathi, Concrete, Gir, Saiwal, Tarparkar, like this. No. Gaushala should inculcate the objective of maintaining, rearing the regional, local type of breeds. A Gaushala from, say, for example, the Nashik region should emphasize for Dangi breeds. So Dangi animals should be improved in that Konkan region. They should emphasize Konkan Kapila type of Goshala, and this is most important as per the breeding centers are considered and what we are expecting from the Goshalas. Next one. Sir, please next. Now, what are the strategies to make the available Goshalas toward the breed centers or the breed conservation centers? Number one, target to convert Goshala as a breeding center in next maximum 10 years. This is not a, no change is expected within a day. So 10 years strategic program needs to be chalked out. Number one. restrict Goshala cows for maintenance, care, senile management, and level of 50% of total herd in next 10 years. So 50% animals, if a Goshala is carrying 100 cows, out of that 50% animals means only 50 cows, we should take care for their best managemental practices, best care, best senile also. The unit, they should have this care and the nursing of senile animals. But 50% animals at least we should bring under this type of a plan for best and ideal type of management system, at least for 50 cows in next 10 years. That is most important. The third one, improve body score condition of 10% cows yearly to make them fertile and provide productive for genetic improvement. Out of 100, every year we have to make only 5 cows, because our target is to make 50% cows ideal. So out of 55 cows in a year must be such a type of cows which should not be available at any place outside the Goshala. A Devani cow having potential of 25 liters of milk yield, such a type of 5 cows must be available in Goshalas, and that should be the target. That should be the target. So improvement of body weight, improvement of body score condition, that is the first and the foremost thing for such a type of the objective. The next one is that provide perfect partitioning between male and female cattle. Very, very important. Very, very important. If you are visiting any type of Goshala, never come back unless and until you emphasize on partitioning of male and female animal, because many Goshalas, they have one Nandi, which is generally purchased from Gujarat, and that particular Nandi covers all cows, whether those are ailing, whether those are diseased, whether those are say fractured. That Nandi will cover all type of cows, and we are getting more and more non-discriminatory purebreds and nondescript cattle in different partitions. Every Goshala has purebred at least 5 to 7 Hilar animals, 3 to 4 Lal Kandhar animals, 2 to 3 Dangi animals. So these type of purebreds, we should not mix them into the other type of groups and the total group. It is only because any visitor, if he comes to the Dangi unit, he should proudly say that yes, these are the 2 Dangi cows. These are the 2, say, Lal Kandhar cows. So likewise, the grouping of those purebreds will be important one as far as the educating the visitors. This is most important. Next one is that accept one breed Goshala policy for each 100 inmate. This is very much important. If I have a Goshala of 100 cows, I should strive hard for making one breed Goshala. If a private Goshala is there, if a owner is maintaining the cows as Goshalas, 30 cows, 40 cows, also he should think positively that he should have only one breed cows. Panganur, I will keep. Kankraj, I will keep. Rathi, I will keep. This is not the policy. This is not an acceptable type of the thing, because many organizations, they cannot sustain financially if we are maintaining n number of breeds at one particular platform or one particular unit. So every time all 100 cows from Kilar, all 100 from Gir, that type of Goshala is expected. That is called as the Goshala. Otherwise, it should not be a dumping hub for all nondescript type of the animals. Next one, the breed-wise classification and partitioning, that is most important one. Yearly, at least 20% elite cows and productive cows must produce calves. The same thing I told, that the cow should be productive one. Do not go for any type of milking. Let those cows be reared with the cow milk. But cow should prove its potential that yes, that is a elite type of cow. Such a type of cows you can spare for the breeding to the Breeders Association. You can ask elite males from Breeders Association to Goshalas. Exchange program must be a regular one. My cows, I will not say spare for any type of farmer, any type of association, any type of government agency. That is a narrow-minded approach. Free exchange of the animals after testing, after scientific approaches is necessary, then only Goshalas will develop, and then only the surrounding population of that particular breed will develop. The next important is that breed all nondescript cow to a single fixed breed. So a Goshala is having 50 nondescript cows. Fix the strategies that I will convert my Goshala into a killer Goshala, and therefore hereafter I will use only a killer bull semen or the killer semen, killer natural service for breeding of all those nondescript. After 7th generation, you will find that total number of the inmates, definitely they will be killer, pure bred killer. Such a type of animals can be made available in the Goshalas. Next approach is the seek technical advice for genetic improvement of cattle. Every Goshala should opt the information. They should ask for the scientific approaches. They should ask for scientific strategies from government agencies, from the expert, whosoever they feel as an expert. That particular fellow should be called, and regular type of meetings are necessary to genetically improve the stock. That is most important. This is not happening at present. Friends, this is not at all happening. Gaushalas are not interactive. They are not interactive to the farmers. They are not interactive to the scientists. They are not interactive to the government official, and therefore there is limitation in maintaining of the animal. Next one, yes, the strategies are more important, and then we are going to stop in 10 minutes. Next slide, please. All right. The next strategy should be that reproductive biotechnologies are necessary in minimum elite cows allocated for the breeding. If a Goshala is allocating 10 cows, so these 10 cows should go for embryo transfer program. These cows should go for sorted semen, artificial insemination. These cows should go for synchronization of estrus. If experiments are conducted in Goshala with the elite cows, that will be a news. That will be an identical path. That will be an ideal path for the farmers to follow. And that is most important. Monthly technical review is mandatory for genetic improvement. Very, very important. If we want genetic improvement of the animals, definitely there is a necessity to discuss, interact, and to decide the policy for improvement of the cows. Gaushala should provide advisory services to farmers and the breeders. Yes, Gaushala should be the education center as a breeding center. The next one is the education center. Gaushala should provide the information. If you want a Devni cow, see, this is the type of phenotypic characters in case of Devni cows. If you want to breed Devni cows, this should be the approach. If you want to rear Devni cows in an ideal manner, advanced scientific practices are like this: loose housing system, chaff feeding, and so many other type of things we know. Such a type of the things, educational training center should be the Goshala. Goshala should be the educational center for the adjoining farmers. The next one is the individual records are highly essential for breed conservation. So all animals and their records are necessary. Goshala should keep it. This is the very important and very essential need of the hour, because every time Goshalas are failing to improve only because of the records. Record of purchase of fodder, purchase of feed, purchase of medicine, vaccination, the health, that is must. But most important is regarding the breeding. Most important is regarding their improvement, genetic improvement. So that type of records must be maintained. Superior germ plots should be made available through insemination straws. So accept at least 10% animals for artificial insemination program. See the miracles which you are going to have benefits through these type of improved varieties of that purebreds through artificial insemination. If you have good one, provide it to the artificial insemination center, provide it to the farmer breeders. So this exchange program is necessary. Purebred exchange program is just possible with adjacent farmer. Then the next one is the prefer local and the regional breeds only for conservation. Again, I have repeated this particular point here. Exchange of out of interest breeds to other goshalas. My goshala is a Khilar goshala and I have 3 Gir cows. Why not to spare these 3 cows to the Gir maintaining goshalas and get another 4 cows from Khilar goshala? This can be a out of interest exchange program, and here it is not the wealth. It is the breed improvement which is expected by the society, by the Indian people, and for that purpose, such a type of broadness of mind is necessary from the Goshala owners. The next one is the least out possible productivity and utility potential of the cows. That's what we have already discussed. Improve experience, involve expert and experienced scientists for improvement of the Goshalas. Prepare breed libraries with references, prints, books, videos, breed training centers for benefit of the rural poor farmers. They will approach to the Goshala. A Goshala should have a training center. They should have a television set. They should have computer set. They should provide internet. They should provide the information on, say, for example, concrete breed. Entire information should be there. Information for cow products, that should be made available. The books must be available. The reading material should be available. Videos must be available. We should also include the spiritual type of lectures. Nothing wrong in it. We have a very religious approach toward the cows, and therefore let there be the deliberations from sants, months, and so many other type of the elderly people who are very much interested in conservation of our breeds. So that type of center is necessary. And the last one is the promote, participate, and organize breed improvement programs. So whenever there is opportunity, regularly 6 monthly interval, the Goshala should organize the breed improvement program. So that type of sea change is expected in case of Goshala through strategic approaches. Next one. Yeah, now we are coming to the end and only 2 or 3 slides are remaining. Friends, many Goshalas, they say that milk should not be our revenue. Fine, accepted. But cow dung and cow urine must be utilized properly. It should not go waste in any Goshala. This particular urine and dung should go to the soil for improvement of soil carbon. Indian Goshalas are a rich bank of resources, but this bank is observed as an empty and bankrupt type of the institutes nowadays. So every Goshala should feel that the Goshala is rich with the resources, and therefore every unit of cow dung and the urine must be utilized for proper type of utility. The native cows are production centers of quality manure and insecticides for agriculture purposes. Now, we have already discussed this particular topic, how the cows are important and they are beneficial for improvement of organic type of farming. Promote organic farming, zero budget farming, residue-free farming, and the Indian cows, they can play a very significant role through this. The next one. Last but one, I think so. C. We are using manure regularly for different type of fertilizers, but no cow is buried for samadhi khat after the death of that particular cow. And samadhi khat is having more value than the market value of the cow. If market value of cow is 50,000 rupees after death, and if we make samadhi khat out of it, the cost of the samadhi khat is nearly 2.5 lakhs to 3 lakhs. So we are losing this potential. Our ancient literature indicates that there is utility of samadhi khat. You search YouTube videos for samadhi khat and you will find that at least there are 1,000 videos on samadhi khat. So every cow must be buried, must be made into the particles, And these particles are really useful as a fertile manure for the soil. So please remember about this placental khat. Also, we can make the manure out like this. Enrichment of the soil is possible with Jivamrut, Ganamrut, Vijamrut. N number of Amruts are there. Every Goshala should provide freely. We know that. Gopal Ratna awardee from Gujarat is providing the Jivamrut to every farmer on free basis. The same thing should be available in every Goshala. Gaushala should either utilize cow dung and urine for regularly used domestic product preparation. Yes, they should either use these type of the things for domestic product preparation. I told that 2,000 plus products are there. We have seen through this Gautech 2026 at Pune that n number of products are being prepared by the skillful people through cow dung and the urine, and there is utility for these type of products for Indian domestic utility. Next one. Next. Right. This sustainable agriculture is possible through bull energy also. Nandi Shalas are being established in Andhra Pradesh. Friends, please go through the YouTube videos of Nandi Shalas and you will find that a bull which is not useful in agriculture purposes is very much useful for generating the energy, and he can generate energy for very many purposes. It is estimated that bull is able to produce 10 to 20 units of electricity per hour by his pulling power. Such a type of energies are to be used from the bull energy, and our elite agriculture university centers, UAE, utilization of animal energy centers, they are providing the inputs to the farmer bidders, to the Goshalas that utilize the energy for this purpose. You will surprise that many Goshalas are self-sufficient through the bull energies, and therefore utilization of bull energy is also possible along with the cow dung and urine. The word of caution, I would like to submit that if we are not accepting the milk as the source of revenue, but weak, debilitated, diseased, senile, ailing type of animals cannot provide potential type of urine and potential manure as a through dung for improvement of soil fertility or human health. So every time we want elite type of animals, elite type of cows, and that is only possible through Goshalas. I think I have covered many aspects to convert these Goshalas. Mentality of administrators of Goshalas that needs to be changed in the next 5 years, and only society can do it. And this is possible with our constant pursuing type of approach. Thank you, sir. Thank you very much for giving me this opportunity to present my thoughts regarding conversion of Goshalas into breeding centers, genetic improvement of the cows, and conservation of the breeds, also for conservation of agriculture and sustainability of the agriculture. Sir, thank you. Balarao, sir, thank you.
Thank you, sir. Thank you very much for a very nice presentation. In-depth knowledge about the Goshala is given by the sir. I request participants to please ask some questions. If there are any queries, I request all the participants, students, farmers to ask any question. If there is any queries or question. This seems like there is no question. Sir, thank you very much. Today's session, role of Goshala in the conservation of the indigenous cattle breed and promoting the sustainable agriculture. Today's speaker is respected Dr. Nitin Markanday, sir, ex-associate dean, Veterinary College of Agriculture, Parbhani. So from the behalf of the organizing committee and from the project, I am very thankful for this lecture. Very thank you, sir.
Thank you. Thank you very much.
Thank you, sir. Okay. For all the participants, I request they will join at 2:30 p.m. Now we will take the break for some time. Rest of the lectures will be delivered after 2:30 p.m. For lunch, we will take the break. Thank you very much. And after that, after the last session, we will present the abstract in the form of the poster as well as oral presentation. So I request all the participants after the last lecture, we will present their posters and oral presentation. So thank you from me. We will take the break for some time. Okay, thank you.